from Microsoft MVPs and other industry experts who are going to help you get up to speed on the latest in DevOps and Azure and just get a better understanding for some of the processes to deploying things, to managing things, to networking things, to thinking about your digital transformations, all wrapped up into a virtual conference right here on Petri.com, or you might be on YouTube or Twitters or Facebook, everywhere else we are streaming. We want to thank our friends over at Kemp for helping sponsor for today's event. We very much appreciate them. And throughout the day, you're going to hear from industry experts and Microsoft MVPs. But first, we're going to be kicking it off with Aidan Finn, who's going to be talking about networking and a whole bunch of other stuff inside of Azure that you really need to know. And what you need to do throughout the day is check out the links down in the description below to make sure to download the handouts. That's going to help you take away some items that you can reference later. And of course, all these sessions will be available on demand after today's event. But here we go. We're going to kick things off here in just a couple minutes with Aidan's session.
Hi everybody, my name is Aidan Finn and welcome to this session called Azure Networking, the First Technical Challenge. I'm Aidan Finn. I'm a 13-year Microsoft Valuable professional currently with the expertise of Microsoft Azure. I'm the owner of a company called Cloud Mechanics where I develop and teach my own Azure training materials. I'm full-time employed as well by a company called Innofactor. I work for the Oslo office in Norway where I am a principal consultant working with Azure infrastructure, specializing in networking, security and governance subjects. I've been working in IT since 1996, covering a lot of different areas, including things like Windows Server, Hyper-V, System Center, Desktop Management, and obviously Microsoft Azure. I write on my own site on aidanfinn.com. I work for Innofactor. You can find on innofactor.com. You can learn about my company on cloudmechanics.com. You can follow me on Twitter as @joe_ly. And of course, you can read my monthly Azure article on petri.com as well. Why should you care about networking in Microsoft Azure? Because surely networking in the cloud is kind of irrelevant? Well, that couldn't be more untrue. Networking is always relevant in the cloud. In Azure, networking is always present, whether you see it or not. So you have some obvious scenarios where you're going to be working with virtual networks, and that's virtual machines or infrastructure as a service or IaaS. But you're going to have some less obvious scenarios as well, such as platform as a service or PaaS. And your organization may have the ambition of saying, we're only going to do PaaS or platform. We're not going to need to do any networking. Well, that's not quite true, and I hope you'll understand that at the end of this session. The network is playing a bigger role than ever in platform as a service. Yep, we've got things like governance and security frameworks that are going to be built up, and we're going to connect platform to our networks to enforce our governance and security. We have national and industrial compliance requirements that may require some privacy. And you may even want to optimize the performance and connectivity to your platform services across the internet. So you're going to be looking at performance enhancements that Microsoft networking features can offer. I said this is the first technical challenge. If you're following Microsoft's guidance on implementing the cloud for the first time in your organization, you may end up using something called the Microsoft Azure Cloud Adoption Framework, or CAF. And this diagram shows you at a very high level what the cloud adoption framework is. If you go and look at the documentation, you'll find there's a lot of documentation, a lot of steps, a lot of process to actually go through. For a small medium business, it's going to be way too much, but the constructs and the concepts of the cloud adoption framework are still very valuable, and I would recommend you go through these processes in the order that Microsoft has presented. So firstly, you're going to define your strategy. And that's where you engage with the business, whether it's your employer or a customer, and try to understand what are the business goals and objectives for adopting and using the cloud. Then you're going to move into the plan phase. Now, this is where you're going to get an understanding of the existing infrastructure at a high level. And you're also going to start readying the organization. So that may be building up the skills matrix, identifying who's going to do what and who needs what sort of training. Now we move into the technical part. So govern and manage, there's technical elements to that as well as business elements. But when we move into ready, that's where we're going to be doing the Azure networking. We're going to be building what's called the landing zone. And this is what the virtual network and the constructs that your resources are going to be using to connect to each other, connect to your organization, and connect to the internet. Then you're ready for the adopt phase. That's where you're going to be migrating any existing on-premises or hosting workloads that you want to move into Microsoft Azure, and then you're going to start building your new services under Innovate as well. So let's talk about that virtual network, that thing we're going to be building in the ready phase for our landing zone. I want you to understand that you do not need to be a networking guru to do networking in Azure. I always like to tell people when I'm talking about Azure networking that I have never done on-premises networking. I've never created a VLAN. But in my day job, I am the person that people come to when they want to do Azure networking and Azure networking security. That's because I've worked at it and I've learned how the technology works. Now, you don't need to be a guru at networking at this stuff. You don't need to be a Cisco CCIE or any of that. You just need to understand basic things like subnetting, how packets flow from A to B, so concepts of routing, and understand the basics of firewall rules. If you can do that, you can do Azure networking. What I've found is the person who thrives at this is typically the server admin. And the person who struggles with this, ironically enough, is the networking admin, because they have a lot of preconceptions about how a network functions. And they don't understand that the Azure network is different because it's software defined. We use virtual networks to connect primarily virtual machines, but under the covers, all platform services, or most platform services, are built using virtual machines or containers, which run in virtual machines. So there's always virtual machines, even in serverless computing. Whether you're deploying virtual machines explicitly yourself or using platform services, you're always going to have some sort of virtual network. Not to mention the fact that even if you're building platform services that are going to be on the internet, and you're not doing any private networking or site-to-site connectivity, there is still going to be some element of networking for people to get across to get to your services. Some platform services have very explicit ways of connecting to a virtual network. So you'll have expensive SKUs of the app service environment, SQL managed instance, API management, and more that can connect to a subnet and have a private IP address. But this year, we've seen Microsoft introduce Private Link and Private Endpoint, where we can now connect just about all platform services. And the goal of Microsoft is that all platform services will be able to connect to a subnet and have a private connection with a private IP address to ensure compliance, governance, and security for those services. As I mentioned just a few moments ago, a virtual network is software defined. It's an abstraction of the physical network, so you cannot see the physical network in Microsoft Azure. You can go onto the Azure portal, or you can use one of the many infrastructure as code tools to go and build your own virtual networks with no interaction with Microsoft. That's because you're building a virtual network that sits on top of that physical network. Your data transmission is encapsulated. So you're seeing packets go across your address space, but what you don't see is that your packets are being encapsulated and being sent across a physical network. From your perspective, packets always go from source to destination without any hops. So even if there's default gateways or anything like that, You don't see those. When you're running tools like ping, you're not going to be able to see a default gateway. You're not going to be able to see something called the Azure Load Balancer. These things are handled in the fabric along with routing. The virtual network has a bunch of components. It's actually relatively simple. So when you create a virtual network, you'll typically assign it one address space, although you can assign multiple address spaces. And that address space will be divided up into subnets. So this is where you're using your CIDR blocks and you're doing your subnetting, so your /24, /25, /26s and all that stuff to break up your address space. And the address space of that virtual network should be unique within your organization, so it can be routed to and from other virtual networks and your on-premises networks and any networks you may have in other hosting facilities or clouds. You can define DNS servers for the virtual network, which are then picked up and inherited by the subnets and any resources connected to those subnets. You can have one or more subnets. You must have at least one subnet in a virtual network. It'll have a name, some human-friendly name. Again, it'll have an address space that is a subset of the virtual network, and it will have a default gateway. Now, that default gateway, you will not be able to ping it. It is more a representation of the first hop, but it isn't actually really there. It's a function of the fabric. So don't fall into the trap of trying to ping it or trying to identify it in a trace route because you will not see it. We have two types of IP addresses in Azure. We have a public IP address, or PIP, and we have the private IP address. The public IP address is used to connect resources to the internet. And in the Azure world, internet basically means anything outside your virtual network or your connected networks. So the networks that are connected to that virtual network. That includes on-prem and other virtual networks. The address is assigned by Azure, so you can't bring your own public IP address blocks to Azure. And that address will, by default, stay with the resource it's assigned to while that resource remains allocated. And that means it's in a billable state. In other words, it's running. However, some resources will allow you to set the address to be static. Now, those addresses where the IP address is dynamic, they never get deallocated. There are certain types of platform functions where you just can't turn them off. So there's no actual downside to the addresses being dynamic in those cases. But with the case of things like virtual machines or virtual appliances, you probably want to set those public IP addresses to be static. The private IP address is an address that's taken from part of your subnet. So when you connect a resource to a subnet, it will get a private IP address. Now, the functions of this will look like DHCP and has the language of DHCP when you look at it in the Azure portal. However, there is no DHCP because Azure Virtual Networks do not handle broadcasts or multicasts. They're just not done. You only have unicasts. The address will remain allocated to the resource while that resource is allocated. So in the case of a virtual machine, while that virtual machine is running, it will keep the IP address. So the addresses are dynamic by default, but you can set them to be static, and we'll talk about that in a moment. The private IP address is not routable on the internet. So the resource that has a private IP address needs some sort of public IP address association, whether it's directly or indirectly through another platform resource. There is support for IPv6, however, it is very limited. So basic resources that do support IPv6 include virtual networks and virtual machines. But you'll find a lot of critical platform services do not support IPv6. So if you are doing IPv6 and you must do IPv6 in Microsoft Azure, you will be looking at third-party appliances to enable connectivity and routing to your virtual machines running in Azure. Now, we've talked about virtual machines, so this is where most people actually start off in Microsoft Azure, and it's where most organizations spend a lot of their early days when they're migrating their existing workloads to the cloud. So it's important to understand how virtual machines are networked and how they get their addresses. A virtual machine, when you deploy it in Azure Resource Manager, has a NIC, and that NIC is another resource that lives outside of the virtual machine. The virtual machine is associated with the NIC, and the NIC is associated with the subnet. That virtual machine can have multiple NICs depending on the spec and the size of the virtual machine, and they can connect to different subnets in the same virtual network. When the virtual machine is powered up or goes into an allocated state, the NIC will request an IP address from the subnet, and the NIC will be assigned the first available IP address from the subnet address space. It'll be assigned the subnet mask, the default gateway, and whatever the DNS settings are from the virtual network. However, we can override those DNS settings on the NIC and explicitly assign DNS servers of our own choosing for that NIC. For example, if you were deploying domain controllers using Azure Virtual Machines. That address that's assigned to the virtual machine is dynamic by default. So when we power down or deallocate that virtual machine, the NIC will hand back the address to the subnet. And if we have multiple virtual machines in that subnet and we power them up in different orders, well, our virtual machines might end up with different IP addresses. And for legacy workloads, that will cause a problem. The wrong thing to do is to log into Windows or Linux in the virtual machine and set the IP address in the guest OS network configuration. That's a typical rookie mistake in Azure, because what happens is your virtual machine will lose connectivity. You'll have to go through one of a number of different possible hacks to get your virtual machine back on the network again. Instead, if you want to give that virtual machine a static IP address, go to the NIC resource and set the IP address as static there. In the guest OS, it will still appear to be dynamic, and you might get warnings from different things like Active Directory, domain controller promotion, that you have a dynamic address, but you don't, because you are always getting the same IP address over and over. So you don't need to worry about that. And as I said earlier, you can also edit the properties of the NIC to customize the DNS settings. So you can use different DNS settings than the virtual network. Azure offers a number of different networking features in the platform. So we have different things that we're going to look at, like Layer 7 load balancing, web application firewalls or WAFs, network firewalls, site-to-site connectivity and routing, software-defined WAN, and so on and so forth. But there are a number of third-party offerings out there as well. The Microsoft platform services do probably 80 to 90% of what most organizations actually need. However, there are a rare number of occasions where you're going to need a third-party appliance. These third-party appliances run as Linux virtual machines, and you'll find them in the Azure Marketplace. If they're in the Marketplace, it means they're supported by Microsoft Azure. They do come with the complexity of running infrastructure as a service. So now we've got virtual machines that need to be maintained. We have OSs that need to be updated. And we have sometimes issues with high availability, particularly with routing appliances that would be used for site-to-site connectivity. And the other issue we have in that particular scenario is that there is no propagation of routes into the Azure Virtual Networks. So if we're using BGP to propagate routes across a site-to-site VPN connection, BGP routes will not be injected into the virtual networks. And we also can't use the local network gateway resource to inject those routes into the virtual networks. So that means we're going to have to do a lot of manual route manipulation, which is going to be quite costly if you have a large network address space or a complex address space or an address space that's constantly changing. One of the first platform resources you're going to use for networking is going to be the load balancer. This is typically associated with virtual machines. However, as I said, platform services are typically built using virtual machines, and many platform services use an Azure load balancer under the covers. So it's useful to understand how the load balancer works, in particular when you're configuring firewall rules or network security group rules in your subnets. The load balancer allows you to aggregate virtual machines or services together and present them as a single service through a shared front end. That shared front end can be a public IP address or a private IP address. And we can use that load balancer to scale out, so we can do high availability or scale out of our services across multiple machines. And we can also implement NAT rules, so we can take a single public IP address and use it to translate external ports back to private ports. So we can reduce the number of public IP addresses that might be used with virtual machines. Typically in the infrastructure world, if you're doing things well, the only time you're going to be using load balancers is for private deployments or in the public scenario with virtual appliances that do happen to support scale out and high availability. Public IP addresses, as I said earlier, allow us to connect to the internet. It's a publicly routable IP address that is assigned to you by Microsoft Azure. It can be assigned to virtual machines, but we typically try to not do that. but it is more often associated with Azure resources, and that may be to make that Azure resource available on the internet or to make it available to Azure for its control plane. A public IP address can have a Microsoft managed DNS name, and I would typically recommend that you do that or implement that DNS name to simplify the management and identification of that public IP address, and it also opens up some other features such as Traffic Manager, which we'll look at later. The public IP address is dynamic by default, however, some resources do allow you to change it to static, such as virtual machines or load balancers. The public IP address can be assigned to virtual machines. And if you go into the Azure portal and create a virtual machine by going next, 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 you know what? That's what's going to happen. You're going to get a virtual machine with a public IP address. What's the Azure portal trying to do there? Well, it's trying to make it easy for you to get a virtual machine up and running that you can connect to. Because part of what the Azure portal is trying to do is sell you on the concept of using Microsoft Azure. Hey, you wanted to get a virtual machine up and running, you want to sign into it, you want to enable IIS and browse it on the internet. Hey, we can make that really easy for you. But it's too easy because it's not really secure. Think about your on-premises data centers or hosting facilities. How many of your machines have a public IP address associated with them? Not that many, because it opens up a huge security footprint. It means there's a lot of openings there that attackers can go after. There's too many ports open for security people to control that environment. So yeah, assigning a public IP address to each of your virtual machines, yeah, it's easy and it's handy. However, it doesn't scale well or at all. It's very hard to manage and secure. There's a lot of wasted money because those public IP addresses actually have a cost. You don't need to have one public IP address for every virtual machine. There are better ways to access your virtual machines, whether it's to log into them via SSH or RDP, or to access the services that those virtual machines are hosting. It also makes it really hard or near impossible to do load balancing or scale out. So you're going to be looking at single virtual machine workloads, which a cloud is not really designed to do. So how do we securely log into our virtual machines using RDP or SSH? Well, the newest way of doing it is using a feature called Azure Bastion. This is where we deploy a resource called a Bastion into a dedicated subnet called Azure Bastion Subnet. That could be in the virtual network, or if you're doing something called a hub and spoke architecture where you have a central network for transit and connectivity, and you deploy your services into spokes that are peered back to that hub, then you can deploy that Azure Bastion Subnet into that hub or transit virtual network. This allows you to sign into the Azure portal where you're authenticating using Azure AD and things like multi-factor authentication if you've enabled it. And you can click on connect for that virtual machine and you'll get a new window open that allows you to SSH or RDP into that virtual machine. It's not perfect, I admit that. It lacks some features, but I have found it's the best and most secure way to enable access to your virtual machines, particularly for remote workers or vendor support. We have another option as well in Azure Security Center called Just-in-Time VM Access or JIT VM Access. And this uses a feature that we'll talk about later called Network Security Groups and creates a firewall rule to block RDP or SSH to your VMs. And then you can request access to a virtual machine and Security Center will pick up your public IP address from whatever location you are at and will allow your requested protocol and connection to that virtual machine and that virtual machine only for a limited amount of time. And you can select how long that time will be. When that time expires, the rule that allowed that access will be automatically removed. So that means the hold to RDP, SSH, FTP, or whatever it is into that virtual machine will only be there for a very brief amount of time. Another approach that people have taken is to deploy a gateway using virtual machines. So this is technology like Citrix or Remote Desktop Gateway, or even open source things like Guacamole. We have one or more virtual machines that are used as an air gap to hop securely into your backend virtual machines over RDP or SSH. A lot of organizations have decided that they want to build applications to be as modern as possible. That means that they're building clients that are HTTPS clients. Now, this is great. This is awesome because it deals with things like latency. HTTP, HTTPS is designed to work over latent connections. And we have ways of even optimizing that depending on the type of content we're presenting through our services. It's already secure, it's already private because of SSL or TLS. However, we do have legacy systems out there that we're going to migrate to the cloud and that will require a site-to-site networking, RDP or SSH, and client-server latency might be an issue. So we can't say that everything is going to be a modern service deployment. However, if we are building a service from scratch, building it to be available over HTTPS is just a logical conclusion. And we can strengthen that with authentication and authorization from services such as Azure AD. We can make it available to anywhere, again, subject to things like conditional access controls. And this is a great way of making services available to work from home, roaming workers, suppliers, customers, and partners. If we're doing something like that, a way of presenting services as HTTP workloads to the internet or even to on-premises over a private connection is to use the Azure Application Gateway. And this provides us a layer 7 load balancer for HTTP and HTTPS built services. It uses a front end, a single IP address, that could be a public IP address or a private IP address, and it can host a single site, multiple sites or applications. It can be used as an ingress controller for Azure Kubernetes service. It allows you to do SSL offload, so you can reserve the processor of your web or application servers, so they don't have to do that encryption, de-encryption work, and do that instead on the application gateway. If you need to have end-to-end encryption, you can have a different certificate set up on your app services or your Azure Kubernetes services or your virtual machines, and re-encrypt the traffic as it reverse proxies through the Azure Application Gateway. And the application gateway, which is built using load balancer and virtual machines, which you don't see under the covers, it will have a limited amount of capacity, but you can configure it to do automatic scaling. So it will scale in and out based on demand. The services can be built on virtual machine scale sets, Azure App Services, Azure Kubernetes Service, and actually any valid endpoint. So that includes services that are working on premises and you can connect to over your site-to-site VPNs or express route connections. A different way of presenting services that are built using HTTP or HTTPS is Azure Front Door. And the Azure Application Gateway gives us what we call regional load balancing or local load balancing. So services that are built within one location and we can scale them out. Azure Front Door works at an inter-regional level. And this is a service that is hosted in Microsoft's edge data centers. Now you might have heard, yeah, Microsoft had data centers. That's the wrong term to use. They have regions. There's over 50 regions around the world. And that's each of those regions is made up of multiple data centers. And that's where your services are actually running. However, Microsoft also on their WAN have these edge data centers. And these are smaller locations, points of presence, connectivity nodes if you want to call them that are dotted all around the world and are connected and wired directly into Microsoft's WAN. And this gives our clients, which are out on the internet, a close by entry point into the Microsoft WAN and therefore a low latency connection path to the services that are running in the Azure regions. This is a technology that was built for things like Xbox Live and Microsoft Office, and it was made available to Azure customers. This allows us now to start scaling out at a regional level, doing high availability at a regional level, plus reducing the latency to get from the client to the backend server when an interactive connection is required. If we're dealing with static web content, then you might want to look at a content delivery network. Now, there are lots of these available out on the internet, and Azure has an offering as well called the Azure Content Delivery Network. Again, taking advantage of those edge data centers. And these are designed to handle the many HTTP requests or HTTP gets for static content. This is content that doesn't really change very often. And we can put it into cheap storage, such as blob storage in a storage account, and then make it available and replicate it out to all of the edge data centers around the world close to our web clients using the Azure Content Delivery Network. Now when that client does a HTTP GET for that static content, instead of having to transit across the internet or even across the Microsoft WAN to get to our app services, the connection is delivered directly from the point of presence or the edge data center. And that reduces the latency for getting that static content. So things like images, etc., they're usually quite costly to deliver. This also reduces the amount of CPU and bandwidth that's consumed by your web services. And we can focus them instead on the more interactive engagements. So for example, when someone actually clicks purchase on their shopping basket. That load balancer we talked about a little earlier, well, earlier this year, Microsoft Ignite, Microsoft announced that the load balancer is going to now support cross-region load balancing, scale out, and high availability. Now, I've just talked about something called the front door, which does that sort of thing. However, front door is designed to work with HTTP and HTTPS workloads and doing reverse proxying and other cool stuff that you typically associate with that type of workload. The load balancer is designed to work with any port. So it's not restricted to HTTP, HTTPS. So we can deploy our backend services across multiple regions and we can redirect our traffic to that closest region. We have instant global failover, so we can do high availability with this. We can even do nested load balancers, so we can have load balancers in each of the regions, which are allowing us to do high availability and scale out within the regional level as well. And we have the ability to scale up and down our workloads on demand. A similar technology designed to work again with DNS is Traffic Manager. And Traffic Manager allows us to aggregate our deployments. Now, these deployments are typically referred to as endpoints, and an endpoint is a public IP address with a DNS name. That can be in Microsoft Azure, but it can be anywhere. So we can take a deployment that's in AWS, Google Compute, Azure, and even running on-prem, and aggregate those services into one DNS name. And that allows us to scale out and optimize performance by redirecting people to the closest endpoint based on latency. We can do high availability, and we can also introduce this concept of A/B deployments. So we may have one production deployment while we build up a pre-production deployment elsewhere. And when the pre-production deployment is ready, we alter the traffic manager profile to redirect clients to that new deployment and leave the old deployment where it is as a rollback if necessary. So over time, as DNS records are uncached, clients will be redirected to the newer environment. This service is entirely DNS based, and this is what makes it quite a flexible service. And it's something I would strongly recommend you use where possible if you're building services on the internet. We're going to have legacy workloads that are going to require private remote connections. Those legacy systems may include virtual machines that we're migrating to the cloud. So it could be our Hyper-V workloads or our VMware workloads. Possibly we're using Azure VMware services and we're going to need site-to-site networking for vMotioning our virtual machines to Azure. And we may have legacy deployments of Active Directory domain services that need to be able to replicate to and from a site hosted in Microsoft Azure or sites hosted in Microsoft Azure. And even when we have migrated our legacy workloads to the cloud, they may still need to be able to integrate with other legacy workloads that are still running on premises. And the only way to do that security is over some sort of private network connection. You may have a need to comply with some national or industrial requirements. For example, you might have medical data or healthcare data that must transit a private and encrypted circuit. And you may have requirements to implement service level agreements for your connections. Earlier on, I talked about building services that would be available on the internet. However, there's no SLA on the internet. And if you have some sort of requirement for a service level agreement to be able to connect to your services, that's going to require a private connection from a service provider who can give you that SLA. However, as I like to tell people, an SLA is not a promise of uptime. An SLA is a promise of compensation when there is downtime. So there are ways of building highly available connections without having an SLA by using multiple redundant connections from different service providers that come into your network or your building through different paths. So we have a few different ways of connecting to our networks in Microsoft Azure from our on-premises or external networks. The first one of these I want to talk about is using a third-party network virtual appliance or an NVA. This is where we're using that Linux virtual machine from the Azure Marketplace that has some special software on it that makes it act as a router. And you'll find all your typical names there in the Azure Marketplace. Now this is going to be a virtual machine with a public IP address, and I say a virtual machine because so far any of these marketplace offerings I've looked at have been single virtual machines that do not have high availability. And of course, I mentioned earlier on, they're going to have issues with propagating routes into your Azure network. So if you have any sort of scale out on-prem or in Azure, or any sort of dynamic or rapidly changing network address spaces in your environment, this is going to be very, very hard to manage. Plus, you're going to be dealing with multiple vendor support issues. So if something goes wrong with that site-to-site networking connection and you open up a support call with Microsoft, they're going to tell you, talk to your vendor who built the virtual machine. You talk to your vendor and they're probably going to tell you to talk to Azure. Some of these appliances do support IPv6. So if you have to implement IPv6 in Azure, well, this is the route you're going to go down. And some of these appliances will implement features that you will not find elsewhere in the Azure platform. However, I've not hit a requirement for any of those myself at this point. There are different types of connections that the Azure platform can actually support. We have point-to-site VPN, which is where a user uses their device to VPN to an Azure virtual network. And this can be done using the Azure platform or a third-party NVA. In the case of Microsoft Azure, we can use the Azure VPN client or the OpenVPN client and authenticate using certificate or radius. We can also do site-to-site VPN. Again, this is something we can do with the Azure platform or with the third-party NVA. And this is where we have an encrypted tunnel constantly connected over the internet from an on-premises network to an Azure virtual network. This gives us a cheap way of connecting privately and securely to our Azure networks from our physical locations running outside of Azure. It supports a huge range of third-party on-premises appliances. However, it doesn't come with an SLA. But if you want to counter that whole SLA thing, as I said earlier, we can do multi-resilient VPN connections. And if we have a large on-premises WAN, we could do those connections from multiple locations. And then finally, we have ExpressRoute. And this is the Ferrari of Azure site-to-site networking. This is where we get a circuit from a service provider who will give us an SLA on that circuit. And it will connect us to one of those Microsoft Edge data centers. And that gives us a connection now to the Microsoft WAN, not to our virtual network, but to the Microsoft WAN. And we can use that to hop to multiple virtual networks across the Azure WAN, depending on the spec and SKU of the ExpressRoute circuit that you've deployed. It gives you a very low latency connection, and it includes a number of different interesting architectural features. So we can leverage ExpressRoute to build our own WAN. For example, if we have offices in different continents, they can connect to each other across the Microsoft WAN instead of having connections to each other with a third-party MPLS. If we are going to do site-to-site networking using the Azure platform, we're going to do that using a virtual network gateway more often than not. This is a platform-based appliance. It's highly available. Under the covers, it is 2 load balanced virtual machines that can be configured to be active-passive, active-active, and in supported regions where we have availability zones, we can make that virtual network gateway zonal or zone redundant. When we enable VPN or ExpressRoute, we can enable BGP and propagate routes from our on-premises routers to that virtual network gateway and then into our Azure virtual network where it'll propagate out from there. If we are not enabling BGP on our VPN connection, we will end up creating something called a local network gateway that will be associated with the virtual network gateway, and that will actually propagate the BGP routes into the Azure virtual network for us. This virtual network gateway supports point-to-site VPN, site-to-site VPN, and ExpressRoute. And recently, we have been able to enable site-to-site VPN over ExpressRoute if the Azure region supports availability zones. Another interesting option and a more recent innovation in Microsoft Azure is Azure Virtual WAN. This is built using those same virtual network gateways. However, it's a bigger solution that abstracts a lot of the complexity in building a hub or a transit virtual network. Typically, we associate Azure Virtual WAN with the implementation of an SD-WAN or a software-defined WAN. And this is where an organization is not implementing or is removing an MPLS network and replacing it with a complex web of VPN connections that could be highly available or multi-resilient VPN connections. The Azure Virtual WAN supports site-to-site VPN, point-to-site VPN, and ExpressRoute, and allows us to implement some rather interesting architectures. Now, I did say we typically associate it with SD-WAN. However, the way it handles point-to-site VPN and site-to-site VPN has made it an interesting architecture or option for organizations, particularly with the recent lockdowns caused by the pandemic. It, as I said, simplifies complex architectures. It absolutely decimates the amount of routing we have to implement to force traffic through a firewall. So instead of deploying routing out to every subnet in our virtual networks, instead we implement the routing in a hub resource instead. It allows us to implement any-to-any transit connections. So now we can start taking advantage of the Microsoft WAN as our WAN. So if we implement virtual hubs in different continents, we can have offices connected to a local hub and then connect to each other across that Microsoft Virtual WAN. If we implement point-to-site VPN using the Azure VPN client, we can implement the traffic manager profile that allows that VPN client to connect to the closest deployed Azure Virtual WAN hub, and then be able to route to their office or any of the Azure virtual networks across the WAN, taking advantage of the low latency connections that the Microsoft WAN can offer. Microsoft are working on a new version of the Virtual WAN Hub that will support third-party router appliances. And they have also started some partnerships with some third-party security SaaS vendors, such as Zscaler, iBoss, and Checkpoint CloudGuard. And that brings us to network security. And this is how we're going to secure our services and our data in the cloud. I want you to understand you will still need firewalls. And I want you to think about how firewalls have failed in the past. We have seen ransomware run rampant. We've seen things like WannaCry, which devastated the health service in the UK a few years ago. We saw Norsk Hydro, which is an aluminium manufacturer in the Nordics, that was shut down, and that cost them $40 million. We're constantly hearing about ransomware attacks from the US, shutting down government and hospital environments. And Microsoft isn't immune to security breaches either. So there was a story not so long ago where Microsoft accidentally reduced the firewall rules in front of a database that contained anonymized customer data. And this was a database running in Microsoft Azure that some developers were managing. So we still need to implement networking security. But here's the thing, it's about time we did it right. And that means implementing something called micro-segmentation. Micro-segmentation is where we don't rely on just a single firewall that sits at the edge. Instead, we implement firewalls in depth to protect ourselves against north-south and east-west compromise. So north-south is stuff coming from the internet. Yeah, it's going to pass through the edge firewall, but then we want it to pass through a firewall on the subnet, and ideally pass through a firewall on the resource itself. And that all our resources will be connected to networks to make this possible. And then if our services want to talk to each other, we have east-west protection. And that may be protection between different services, but also protection between the different tiers of a single service. And this is very different to what I observe in customers who are migrating to the cloud. When I start talking to them about their network security, they typically only have the edge firewall and maybe a few firewall rules set up between some VLANs. But once you get inside that network, that network is completely compromised. Securing in depth is much easier to do in Azure because we're doing software-defined networking, and we can even implement change controls and reviews using infrastructure as code techniques. This means we start implementing something called DevSecOps. Now, you may be thinking, hey, I'm going platform, this is irrelevant to me. Actually, it's still relevant. As I said, we can use the network for enforcing our governance and our security and our compliance for our platform resources. Yeah, we have some expensive SKUs that do VNet integration, but thanks to private link and private endpoint, we now have many platform resources that can connect directly to a virtual network using the private link service and getting a private IP address, which is called a private endpoint. That means that our PaaS service is now a private PaaS service connected to only over a virtual network connection. And we can make that service available to the internet using things like front door, Azure Application Gateway, or Azure Firewall, or third-party firewalls, and doing the security where we should have always done it in the first place. And then implement our firewalls in depth throughout our different resources. The first place we can implement that security is at the resource itself. Now, the obvious example here is the virtual machine that has a guest OS firewall. However, how many organizations in their Windows Server deployments have turned off the Windows firewall using group policy? And that leaves that organization open to malware being spread. So ransomware attacks, for example, or worms easily spreading across the network. That guest OS firewall should be up and running and hardening those virtual machines. The resources we deploy, so the platform resources, so things like storage accounts and databases like Azure SQL and SQL MI and Azure Database for MySQL, etc., they all have firewalls as well. And we can enable that firewall to allow or deny connections. So we can say which IP addresses or which networks should be able to connect to our resources. Some resource types have access rules instead of firewall rules. So things like the Azure App Service, which allows you to economically and easily build scaled out HTTP, HTTPS services or applications. These access rules will say who can connect and consume the service rather than who can have a network connection to the service, but it's still a level of security that we can implement. At the subnet level or the NIC level, we can implement network security groups or NSGs. This is a stateful firewall resource and it has absolutely no cost. We can implement this for free, and it's the basic form of firewalling that we can do in an Azure Virtual Network. As I said, we can implement this with NICs, but the network security group team, if you check on docs.microsoft.com, will recommend that you do not implement network security groups at the NIC level, but instead implement network security groups at the subnet level. And this is because we can now scale out our firewall rules across many different machines that may appear in that subnet. That means we can now start taking advantage of things like application security groups with virtual machines. So instead of creating source and destination rules for each individual IP address, we'll tag the NICs of those virtual machines using something called an application security group, and then we'll use that application security group as a source or a destination in our firewall rules. Those rules, which are stateful, allow inbound or outbound rules, allow us to explicitly allow or deny traffic. We can stack our rules, so we can order the rules and how they're processed using priorities. We can use service tags to abstract the Azure Service IP addresses. So if we're allowing an outbound connection to Azure Backup, for example, from a virtual machine, so we can protect that virtual machine, we don't need to know the IP addresses of Azure Backup. Instead, we just say that we want to allow connectivity to Azure Backup. These network security groups do have a form of logging, which I would strongly recommend you implement. And there's two levels of logging. We can implement flow logs to storage accounts. And in most Azure regions, we can implement traffic analytics, where we can send the data to a log analytics database, where we can now consume that in different ways, whether that's for SIEM, for logs, for reporting, for tracking malicious IP addresses. And there's a whole bunch of different advantages to doing that. If you are implementing a pretty serious deployment, for example, hub and spoke architecture, where you're going to have a central network that's used for transit and connectivity, and then you're going to implement your services in different spokes. Or maybe you're building a software as a service application, and you want to have a central hardened firewall in your virtual network. Then you're going to implement something called a network firewall. This gives you a central point of network security that's typically going to be run by your security officers or your network security operators. Um, there are a couple of ways you can implement these network firewalls. You can use a third-party NVA. Do be careful because some of the NVA vendors are quite knowledgeable and do a pretty good job. Some of them are not. So you need to do your research, do your testing, and don't judge it based on the brand name. Some brand names have actually done a pretty poor job and would end up being an architectural time bomb in your virtual networks. On the other hand, you've got the Azure Firewall. This is a platform-based firewall, and this is what my customers typically prefer. They don't want to be managing virtual machines and stuff. What they want is to manage the firewall rules, and they want to manage the security context, and that's it. They don't want to manage stuff. It's a highly available firewall. It's a platform service built using load-balanced virtual machines under the covers, and it is designed to work in a DevSecOps environment. So it's really cool to basically manage the rules and configurations using infrastructure as code in GitHub or in DevOps, and then roll that stuff out using a change control and rollback process through a pipeline or an action. Well, the network firewall is dealing with traffic for legacy applications and handling our east-west and our north-south isolation. If you're presenting HTTP or HTTPS services to the internet, you should really present those using a web application firewall or a WAF, which will give you protection at the application layer. And it will understand how to look for protocol attacks such as a SQL injection attack. The web application firewall can be implemented using third-party appliances and some well-known names in the Azure marketplaces or the Azure marketplace that are well-known and trusted. However, you can also implement the web application firewall from the Azure platform. And this is a bolt-on to two other platform resources that we've already talked about, such as the Azure Application Gateway and the Azure Front Door. You always get DDoS protection in a virtual network in Microsoft Azure. And this is taking advantage of the huge capacities of the Microsoft WAN and the ability to do protection across all of the entry points to the Microsoft WAN for Azure services. However, what you get for free is what's referred to as the basic tier of Azure DDoS protection. This is tuned, or the machine learning for the DDoS protection is tuned based on the Azure region that your service is running in. It comes with no SLA. It is a best effort approach. So if you have services that auto scale at a cost, and there is a successful attack against that service, you will be responsible for the scale out cost of that service. And there will be no real specialized form of support for that attack from Microsoft. However, if you pay for the very expensive standard tier of DDoS protection, the machine learning will take about 2 weeks to understand the profiles, performance, behavior of your services in your virtual network that you've enabled this service on, which will mean the machine learning is tuned to your particular service rather than the Azure region that it's running in. It does come with an SLA, which basically means there is a specialized form of support that can be engaged if you do have a successful attack. And there is cost protection against the cost of a scale out if there is a successful attack against your network. So we've looked at lots of different things. Let's talk about the other side of networking, which is troubleshooting. And this is where you are going to spend a lot of time when you have enabled your landing zone and you have services deployed into that landing zone. Your network is software defined, and that basically means that you need to understand that traffic always goes from source to destination without going through a hop. Unless there is a explicit routing appliance or explicit firewall appliance that you've defined as your next hop. It also means that your legacy tools, which are built on ICMP for doing testing and typically have been misused, won't work here or will offer very little value. So that means traceroute is nearly useless. If I'm doing a traceroute from a virtual machine to another virtual machine or to some resource with a private link, I would expect maybe to see a default gateway there, and I need to understand that I'm not going to see a default gateway because it doesn't exist. It's a function of the fabric. It's not an actual resource with a responsive IP address. So what I need to do now is adapt and change. So I need to firstly enable resource logging. So on my network resources, so things like my firewalls, my virtual network gateways, my NSGs, all those different things, I need to enable resource logging. So that could be to a storage account. It could be to an event hub, so it can be consumed by third-party appliances such as Splunk. Or it could be to Azure Log Analytics, also known as Azure Monitor Logs. I strongly recommend you do this with the Azure Firewall and your NSG traffic analytics logs on day 0. You'd be amazed how often I go to those logs, not just to do firewall troubleshooting, but to understand if packets are actually getting from A to B. Because sometimes it just isn't clear if it is getting there or not, unless you've got guest OS access and you can start using some of the tools from Connection Monitor to be able to see if the packets are getting there or not. Azure Monitor has done some innovations on the networking side of things to help you understand what's going on with your resources using Azure Monitor Network Insights. Connection Monitor is kind of a cool one. This is where we have an agent from Network Watcher running in your virtual machine, whether it's in Azure or on premises, and it is continuously doing checks to see if it can connect to a remote location or a remote agent within a predefined amount of latency. And if not, an alert is generated, and you can then action that alert in Azure Monitor. Network Watcher includes a bunch of different tools to help you understand how your NSGs are working, how your routing is working with next hops, to do connectivity checks, and gives you a Network Watcher agent that allows you to even do a packet capture from a virtual machine NIC. And that produces a .cap file that you can open up in Wireshark. Of course, a handy little tool is PowerShell. I mentioned earlier that things like ping will be probably useless, especially if you leave the default Windows firewall configuration where ICMP responses aren't allowed. What instead I find more useful is to run testnet connection. And this is where it's actually connecting to a predefined port. So I may have a firewall and I want to connect to TCP 445. And that gives me a valid check to see if I can reach the actual SMB service running on that remote virtual machine, rather than can I get a response from the NIC with a simple echo, which isn't quite nearly as informative. And that's it. That's an introduction to Azure networking. Thank you for joining me. I've been Aidan Finn from Cloud Mechanics. You can find out more about me on aidanfinn.com, my company on cloudmechanics.com, my employer at innofactor.com. You can follow me on @joe_elway. And of course, watch out for my monthly Azure IaaS article on petri.com as well.
This session has now concluded. Make sure to download your handouts at petri.com/conferences or find the links down into the descriptions below. We'll have more sessions starting up here shortly.
The load balancer's privileged position in the network means it's ideally situated to power always-on application experience, AX, ensuring resilience and total flexibility wherever applications are deployed and wherever you are working from, home or office. Kemp load balancers are available as a virtual, hardware, cloud, or bare metal load balancer, offering hundreds of features, supporting thousands of applications, including the collaboration and meeting apps used by today's remote workforce. Application templates for all major workloads simplify deployment and guarantee best practice delivery. Load balancing across public clouds, including Azure and AWS. Deployed on all major hypervisors to deliver the intelligent workspaces and desktop virtualization that boost collaboration and replicate in-office environments. Customers in 115 countries with over 100,000 deployments, all depending on one application experience expert, Kemp. More simplified deployments, more flexible licensing options, world-class direct technical support, unmatched value and cost savings. Take control of your application experience at kemp.ax.
Good morning, good afternoon, and good evening. Welcome to how Azure AD, Active Directory, and a load balancer can simplify app delivery. My name is Frank Yu. I'm the Principal Application Experience Architect at Kemp Technologies. I am a technology evangelist that likes to understand the business needs and values based on products and technologies that we build and design. I am traditionally a network engineer, and I like to understand how applications behave on the network technologies and architectures that we build. I look at evolving technology landscapes and how they impact IT architectures and the changing architectures in the organizations. So let's talk about Microsoft 365 and Azure Active Directory, AD, because there's a very tight connection between them and what we're talking about. Number one, Microsoft 365. It's a subscription-based cloud offering on Microsoft applications and services, such as Office, which includes Word, Excel, PowerPoint. It also includes email, Outlook, Exchange, Calendar. It includes things such as messaging services and meeting services like Teams, or file sharing such as SharePoint and many other types of systems, OneDrive for storage, etc. Interestingly, and not very well known by a lot of organizations, is that Azure AD comes with Microsoft 365 subscription. So if your organization is using Microsoft 365, your organization has access to at least a free version of Azure Active Directory. And of course, Azure AD is the go-to single sign-on engine for Microsoft 365 services. So if I'm a user and I access Outlook for Microsoft 365, And I have now authenticated using username, password. Maybe we're using some sort of multi-factor authentication with token generators or JSON web tokens or something. If I now bring up Teams, I don't have to re-enter my full credentials. The system, because of Azure AD, knows that I am already authenticated and have access to this other application without me putting in all those pieces of information again, such as my password. So it's very convenient and it's very useful for Microsoft, and can it be very useful for other things, as we will see. But there's some interesting points here. For example, in 2019, Microsoft 365 adoption reached 79% according to one security company survey, BitGlass. When I say 79%, that means 79% of organizations are using some form of Microsoft 365, this software as a service application system, ecosystem that Microsoft has designed. So it's very, very popular. But at the same time, healthcare organizations, only 30% of them are using single sign-on for all their applications. So they may be using Azure AD and single sign-on for the Microsoft application suite of applications, but you have the PAC systems, which are their imaging systems. You have their Wi-Fi within their hospital or healthcare environments. You have the medical record systems. You have all these other pieces that are using separate authentication systems. So there is no single sign-on. Well, you would think technology organizations, such as the company I work for and probably the ones that you do, are using single sign-on because, hey, we embrace technology. We know this stuff. Only 33% of technology companies, organizations are using single sign-on. And you think, okay, this is security because now I don't have to maintain a list of 7 different or 8 different or 20 different username and password combinations for all these applications because I'm using single sign-on. Single sign-on is great. And that makes security much better. So you would think financial organizations, they have a huge stake for making sure their security is good. Only 41% of financial organizations are using single sign-on. This brings up some very good questions of why these organizations, if they're using Microsoft 365 and it comes with the Azure AD, which has single sign-on capabilities, why aren't they leveraging that technology they already have? 79% of the organizations are using Microsoft 365, but less than a third, or maybe a third, are using single sign-on. Why? Why not? So Microsoft 365 comes with a free version of Azure AD. It's not full-blown 100% bells and whistles. There are premium versions, but it is pretty darn good. In fact, it's been improved lately. In May 2020, Microsoft decided that unlimited single sign-on usage for cloud applications, which is essentially all applications, was going to be available. So there's no limit on how many applications you can do single sign-on for using the free version of Azure Cloud AD. So the barn door is open on what applications you can add. There were questions about security capabilities. So you couldn't do in the free version what they called conditional access, which is a very granular way to do policies for specific applications and types of multi-factor authentication and user groups. But a lot of organizations don't need that. They just want to say, we want the capability to do multi-factor authentication for all our users, for all our applications. So they created earlier in 2019, this concept of security defaults to give that capability. And if you need a more granular version, you can use the conditional access with the premium version. And you have this support for SAML, security assertion markup language, for any application registered with Azure AD. And this SAML concept is like getting a ticket stub or a token from the authentication system to say, I have already authenticated, and this ticket stub is valid for me to access other things which I'm credentialed for without having to re-enter all my authentication information like username, password, etc. So it's very, very functional. How do we access that function? How do we extract that capability for our environments? Let's come look at this use case. So we have hybrid identity for single sign-on. And I chose this use case because it's a little complex, but I think it's a very common one. And it's designed to ease the migration from on-premise to multi-cloud or hybrid cloud architectures. In other words, I'm your traditional old school legacy architecture. I have my own data centers, my own hardware and software, and I run and manage all my systems. So that's what you see on the bottom blue circle in my diagram. And you can see it on the left-hand side of that. I have my own Windows server running Active Directory. And I have my own Exchange server for email system and all these other applications on premise. Now I want to add this cloud concept, Microsoft Azure, Microsoft 365, and that's the dark blue on top. So you can see my Azure Active Directory. You can see my apps in Azure, which would be the Microsoft 365 and other applications in the cloud. And I want to combine all this and make it easy for my end users to access these applications in different environments without having to do, in theory, multiple usernames and passwords to access all these different applications, depending upon where they are, when they, where they sit, and how they were designed. And with this multi-cloud environment, we want to get rid of VPN gateways because VPN gateways tend to be bottlenecks to contained environments. And the concept of cloud and multi-cloud is to get away from these contained, protected environments. Multi-security, multi-application, application anywhere is kind of the concept that we tend to shoot for nowadays. So this is a very good architecture, and especially in today's world, because as work from home business models become more prevalent in 2020 because of the pandemic and because people are not traveling. I haven't traveled pretty much for this entire year, and I'm working from home. The business model changes on what users are accessing what applications, how and why. So we need to make this much easier for the users to access these various applications for their businesses. And you can see here one piece I highlighted in this environment. I actually have two Active Directory systems you can see. I have one, which is my Windows Server version, which is my legacy old school. I own the server. I built the software, or my team did. And they have Active Directory and all the accounts built into it. And now we also have this Microsoft Azure Active Directory in the cloud, managing my Microsoft 365 apps and possibly other pieces. And now we have a connector. So we're going to create this federated system, this 80 federated system, to connect the two Active Directory systems so that they can share information between the two and provide some sort of context for profiles, groups, users, etc. And this is how we're going to bring this all together with this Azure AD Connect, which is part of the Azure Active Directory functionality and tools available. But now the other piece is, how do we bring all these applications into the single sign-on environment, whether it's 365 or my legacy app, web apps, and these other apps in the cloud. I need to bring them together within a single authentication system. And that's where the load balancer comes in. So we're going to provide, the load balancers are going to provide the integration to provide single sign-on capability for all these legacy applications. Whether the applications support authentication through AD or not, that's irrelevant, because now the load balancer is doing the authentication on behalf of these applications. We're going to use the load balancing edge authentication capability to include support for non-Microsoft applications, as well as, in this case, we do have the Microsoft 365 providing application support as well. And we're going to eliminate the need for premium licenses for Azure AD, because you don't need to do all these fancy things with Azure AD, because now the load balancer can take the bulk of that workload to do the authentication in these different environments and provide context and user groups and policies. And the load balancer is doing lots of great things that we tend to think of in terms of providing application availability, scalability, agility, elasticity, your traditional load balancer functionality. And we also add additional security functionality such as web application firewall, WAF. So let's take a look at this diagram in this slide. We have the users on the left-hand side, and we have my applications on the right-hand side. I have some legacy applications on the bottom right. I have a couple applications with a little cloud icon being in the cloud. And if I step through, the user is going to try to access one of these applications, whether it's in the cloud or legacy. And it's going to go make a connection either through the load balancer to legacy applications or to the cloud apps, and it needs to authenticate, needs to authorize. So it's going to go to the Azure AD. You can see that triangle at the top to authenticate, and if necessary, go down to my local AD server in the middle, authorize, and that's that handshake of showing that I'm happy, I got my token, and then traverse to the application with that proper credential. And if I go to other applications, that credential will still be valid through that system. So it sounds a little complicated. So let's step through a couple use cases within this use case environment. So first, let's talk about if I'm trying to access legacy applications. Here, I have my user on the left-hand side, and I'm trying to access a legacy application, which is just going to be sitting behind the load balancer. So the application access request is going to be made to the load balancer, and the load balancer is not going to send anything to the application yet. It needs to make sure that the user is legitimate for that application. So it's going to ask the user for credentials, username, password, token, whatever multi-factor authentication system you have, if you have one. And then it's going to go to my Active Directory system, my identity provider, and this could be local or it could be Azure AD. And it's going to ask, are these credentials for this user valid for that application? And the identity provider, the Active Directory system, might say, absolutely. And therefore, the user goes through the load balancer and gets access to the application. If the user wants to go to application number 2, the user does not have to sign in again. The user goes to the load balancer. The load balancer asks, give me information, and the user will send its SAML information assertion. It'll send it or other sort of token, JSON web token or something to say, here are my credentials. Here is my ticket stub that I mentioned previously to say, I've already authenticated and this is what I'm allowed to access. Load balancer will validate with the identity provider and say, okay, this ticket stub is good. You can access application 2. The user did not have to put in new username, password, credentials because that token was valid. Single sign-on. Sign on once, access multiple applications. Let's look at the use case where not only am I accessing legacy applications, but applications to the cloud. Let's say it's Microsoft 365 and I'm using, let's call it Outlook. So my user is going to go to my SaaS application, my Outlook. I'm going to request access to the application, and your application says, sign in, give me your information. You have never signed in yet, or none of your ticket stubs are valid because they've expired. So I have to put in my username, my password, if I have multi-factor authentication, my other authentication things, and I send it to the application. The application will now validate with my Active Directory to make sure Active Directory says, okay, this user can access this account on this Outlook system and all the credentials check. So now Active Directory is going to send the user this SAML assertion information, this ticket stub, as I like to call it. And now I can send that to the SaaS to say, Outlook, here's my information, here's my ticket stub, and everything is happy. And I access Outlook, I get my email, and now I have a lot of work to do because of my email, of course. So everything is good, but now I want to access another application, but it's a legacy application. It's a web application sitting in my data center that has nothing to do with Microsoft 365. Now you can see towards the bottom half of this diagram, I make my application access request. It goes to the load balancer, the fourth icon in my chain. It goes all the way down to the load balancer. The load balancer says, okay, give me information. I say, I've already signed in. And now we do a SAML assertion between me and the Azure AD, and I get my ticket stub to go to the load balancer and say, look, the system says I am valid to access this application for this user. Please let me through. And the load balancer now passes it through. So now, because I sounded into my Microsoft 365 application in the cloud, I now have my single sign-on. I did not have to enter my username and password again. The system automatically did it for me to access this legacy application in a data center somewhere else, which is completely unrelated to Microsoft 365 because of the integration of the single sign-on. This is the power of Azure AD single sign-on with your various applications in the cloud and on-prem, and using load balancers to integrate the two to create a true single sign-on model for your application environment. So ultimately, reasons to use the free version of Azure AD for single sign-on, for me, is a no-brainer. Microsoft 365 gives you the Active Directory access. It gives you the technology available. It's free. And using load balancers, you can integrate single sign-on, not just for the Microsoft 365 apps, but all legacy apps that you have, so that you can bring them together. So now you can add those internal line of business applications to a common application library alongside those Microsoft 365 apps that are already taking advantage of that authentication. You can publish existing traditional web applications for remote access quickly, because single sign-on means all I have to do is make sure that I've provided the security for the other capabilities of the web application, which the load balancer can do with, for example, web application firewall. But now the authentication engine is that single sign-on, so I don't have to duplicate or recreate the wheel. If I have a multi-geographic scenario for remote access, I don't have to do any redesigning with single sign-on. It just makes it work right. And for example, if I'm using the Azure Application Proxy technology, which Azure has built in that you can use at a premium service, you have to create per geography URLs. You don't have to do this with load balancers and the Azure Active Directory sign-on capabilities. I can publish Azure-based cloud applications using cloud-native load balancing technologies such as KEMP load balancing technologies. I can easily integrate line of business applications into team tabs. So I can have teams with other applications which are non-Microsoft built into Teams by using the Azure AD single sign-on. I can also use this as a foundation support building team applications for web content. So now I can have web content built into my Teams environment if I'm using Microsoft Teams. And if you are, like I said earlier, a premium customer for Azure AD, you have the ability to provide conditional access. So you can be very discreet in terms of which applications, what type of multi-factor authentication for which user groups. And if you're using load balancers, of course, you can provide a lot of that capability with the load balancers. And if you're using the free version, or if you're Microsoft 365 and it comes with a free version, you can now truly provide that single sign-on and multi-factor authentication to web applications at zero cost. Use your existing load balancing technology to do the edge authentication as long as your load balancing technology can. KEMP technologies obviously in this case can, to provide a really unified single sign-on multi-factor, two-factor authentication system for all your application environment at no to minimal cost, because a lot of the technology you already have access to as a Microsoft 365 customer. So choose KEMP. And if you want to try KEMP, we have the virtual software versions. We have the cloud versions for Azure, AWS, of course. And we have the cloud versions for it, so you can buy it. You can actually do it on demand in the cloud through the cloud marketplaces. You can download the trial software at kemp.ax/try. And if you really want to understand more about why Kemps prefer Kemp as a load balancing technology versus the other options, you can go to the URL kemp.ax/y-kemp. Or worst case scenario, feel free to contact us at sales@kemp.ax. Hopefully you found this to be useful so far. And now I'd like to take a few minutes and bring on board one of our senior product managers, Barry Gleason, and really have a discussion with him to understand more about his perspective as an expert, to understand why this makes sense and what the trends are for Microsoft Active Directory, Microsoft 365, Azure, cloud environments, and how we bring that all together with edge authentication. We are here with Barry Gleason. He's a senior product manager at Kemp Technologies. And again, my name is Frank Yu, and we're going to have a quick discussion about this Azure AD and single sign-on. And this Microsoft 365, it comes with Azure AD, comes with Microsoft 365. It's really cool and provides some things. And Barry has some awesome insights. And I think one of the first questions I want to ask Barry, and by the way, Barry, thank you for coming. I'm glad you're here.
My pleasure, Frank.
And one of the questions I want to ask, let's get straight into this. What is the #1 challenge with securing applications today?
Oh, you really know how to start it, Frank. I would say, if you have to boil it down, the #1 challenge, I think, for app security is really taking what the user wants, which is the apps to be easily available when they want, where they want, on particular devices, and so on. And it's almost like we have to look at all that and balance it with all these challenges. So, how do we make sure that the app is secure? So how do we make sure, only users that should be allowed access it can? And then second of all, how do we secure the actual application servers themselves? So, I mean, if you think about it, do you want your critical application server to have to be servicing multiple requests from, bot attacks and things like that? And then third of all, and it's something that props up always when it comes to security, is you can implement all these mechanisms to secure your application and your infrastructure, but how do you keep the UX so that users don't get frustrated? How do you make that balance? If you have to jump through, 10 hurdles to get to your application, maybe people don't bother, and so on. If you make your requirements for passwords and your access requirements too strict, people find ways around them, which has the opposite effect. And we all know that. We know that with password length, and if you make your password policy too strict, people write them on post-its and stick them onto their laptops. So I think it's all about that balance. And the other side of it is, if we think about the landscape over the last 10, 15 years, there's been massive changes, and adapting to those changes is key.
Yeah, those are great points. And this ties into the Azure AD and single sign-on, because you mentioned having the passwords and things. So if I have 20 applications I access with the company, I don't want to have 20 usernames and passwords. And me being the stereotypical person who manages their passwords, I'm going to use the same password for every single one because I'm lazy and I can't remember things. So
yeah.
Having a single sign-on strategy makes a lot of sense to me then, right?
Yeah, like it's funny when you think of passwords, and I think a few comedians have done sketches on this. It started off with, password, and then it became password 123, and then it became password 123 with an exclamation mark. And we've had this evolution where we've maybe had stricter password policies and so on. But the most vulnerable part now isn't even the passwords or what passwords you use. It's the fact you're using the same one across all these services. So as you see, you've 20 services, you use your same email and your same password across all 20. it only takes one to be exposed, one to be compromised, and suddenly all 20 are exposed. And it's funny how that's changed, especially with SaaS, you know, and whatever about personal accounts. If you think about business accounts and organizational accounts, think of how much software now is delivered via SaaS, where maybe previously it was on site. So yeah, this is something that single sign-on for sure addresses.
Exactly. And that's why Microsoft did what they did with Microsoft 365, which a lot of people know as Office 365, but it does more than Office. It does lots of other things. But they made it so that they integrated the Azure AD into it because they wanted to make sure that when I access my Microsoft Word or my Outlook or my PowerPoint or my Excel, that I'm not logging into each one every single time. I log in once,
Exactly.
and then
Yep.
my credentials are good for all of the applications. And then the cool thing here is now they've opened it up so that we can now leverage that Azure AD authentication model for all our other applications by integrating the load balancing technology as that edge authenticator for those legacy applications.
Yeah, exactly. And like, I mean, if you think about your traditional organization who might have had an on-site AD, and perhaps they're moving to the cloud, they're moving some apps to the cloud. Perhaps they might have used ADFS previously for federation and stuff like that. But like having the Azure AD and being able to easily integrate that with your SaaS, or maybe even applications that are on site that you want to expose to the internet, it's almost like the missing piece of the jigsaw.
Yes, exactly. Exactly. So it makes sense for these organizations to really get into this single sign-on strategy. And like I was saying in the presentation earlier, leveraging your Microsoft 365 installation, which you probably already have, most businesses have it already, then gives you the access to this free Azure AD service that you can implement the single sign-on strategy. So it makes a lot of sense. But let's move on to a related point then here. So it's great. We want single sign-on. We want some way to control user access to the entire suite of applications, whether it's cloud or on-prem, legacy, etc. What's wrong with using VPNs? Why can't I just use a VPN for my users to log on to that one central point, one password, one control point to access all the things behind it? Why doesn't that work?
Yeah, like, I mean, VPN as a technology is great. It has its purpose. I think we've kind of used it where maybe it wasn't designed. We've kind of, if I mentioned the shift over the last 10 or 15 years, I mean, let's think of a couple of things. Working from home on a kind of maybe pretty permanent basis these days, but on a very sporadic basis, people are wanting to access their office network at home and so on. And as you say, VPN is the typical use case. But then what happens when you talk about mobile devices? Have you ever tried to use an app over a VPN? This isn't so seamless. And then when you think about, I suppose, the nature of workers these days, there's a lot more, contractors who are, semi-employees who are working for organizations. They may need access to some resources. Do they get full VPN access? Then revocation, what happens when somebody leaves an organization? It becomes quite tricky. I'd even think maybe the most important one then, and it ties back to something I mentioned at the start. VPN is fine, but it's almost putting you down this kind of perimeter network mindset, which I think with all these variables, we're going to have to move away from. So this idea of, you're on the network, it means you're a goodie. You're not on the network, you're a baddie. It's not really feasible. And, there's a lot of talk about this concept of zero trust network access and stuff like that. But I think VPNs, even as the technology, they almost lead us into that mindset that I think organizations are going to have to move out of. And then another thing, SaaS. I mean, if everything's VPN based, then you're going to have, you know, all your software as a service applications almost as a separate thing to manage, and it's very hard to manage those together. So I think that's where single sign-on and just considering, I suppose considering all users as being, you know, unsafe until proven otherwise is the way forward.
Yeah, and the way I see it is these VPN, the concept of VPN is it's a border control agent. It's like your border control. Here I live in the US, so the border between US and Mexico, for example, you go through these gates in immigration, and that's what the VPN does. It's saying you can go through, you can't go through. But once you go through, there's no more control. You have full open access to everything behind that control system. And in today's world, especially with SaaS, you know, software as a service, cloud services, you have Microsoft Azure, of course, Microsoft 365. How to use VPNs to create this container to contain all these applications when they sit everywhere. And especially when work from home, where now businesses are taking applications and tossing them right and left in the cloud and things to make them available to these users. It's very challenging for businesses to say, I need to give access to the user through VPN technologies in these environments, right?
Yeah, exactly. And I'd actually throw in one other thing, which is it can also lead us down kind of inefficient traffic routing, because what you end up having is, you know, if you think about a hybrid application where maybe you have, you know, some servers on site and then maybe you scale up and have some cloud presence, you know, you end up kind of tromboning connections and stuff just because that's the way the VPN is set up, and it's not always efficient. So it's just something else to consider.
Oh yeah, absolutely, absolutely. So when we're talking about authentication and single sign-on, the term multi-factor authentication, two-factor authentication comes up a lot. Can you tell us about a couple things? One is tell us a little bit about what are these multi-factor authentication models, and two, if we're looking at cloud solutions like maybe Azure AD, can you tell us some ways to decide which options are the best for us to pick?
Sure, yeah. Like, I mean, if we talk about MFA, you know, put simply, multi-factor authentication is that, you know, you're not just relying on one factor to prove who you are. So, you know, if we take the traditional username password, if your password is compromised, you know, your account or your app can be accessed as you. So, I mean, the most basic MFA could be just adding a second piece of information to allow access. So there's numerous ways that can be done. I mean, most of us have probably come across it in different forms. You have time-based codes. So, you know, these little key fobs, you click and it generates a code, and that'll only be valid for a certain time. You have SMS-based ones, where, you know, once you try log in with your username and password, you get a text or maybe an app pop up where you fill in a specific code. You have, I mean, you even have the maybe the more traditional way, but, you know, you could have a set of codes that, you know, are printed out that you can keep in your back pocket or keep in your wallet. Maybe not so much anymore, but all of these are just examples of second factors that can be used. And I think, like, if you think of security, you know, adding a second factor has a massive increase in the strength if done correctly. I mean, the only thing with multi-factors you have to consider, you know, is a fob, you know, it's, for example, an app on your phone really providing multi-factor if you're accessing the app from your phone anyway. So if your phone is stolen, they've got your saved password in your browser plus your multi-factor in the same devices, and they're all the things that have to be considered. Which kind of leads me on to your next question, which is, you know, what the best approach is and so on. I think there's no correct answer because it depends on every specific organization. You know, are most of their apps in-house? Are most of their apps SaaS? Is there a mix? You know, the access types. So, for example, are you talking about TIC clients versus web browser access? So with a web browser, it's pretty straightforward to, you know, to give a second pop-up where they maybe have to put in a code. That's not so easy when it comes to TIC clients or server-to-server, application-to-application communication, where maybe you might might be more suitable to use long-lived API keys or API keys that have refresh timers on them and so on. So there's a multitude of things to consider.
Okay, awesome. And excuse me, and that makes a lot of sense because each business is unique, and it makes sense to look at the criteria. Like for example, like you're saying, am I primarily SaaS? Am I primarily in AWS or Azure or Google Cloud? These things make differences and impact what makes sense for you to use as an organization. So awesome. These are great answers, and I'm happy that we're able to get this information for you to share this with our listeners. So my last question for you to tie things off, and this is a challenging one, actually. I think it is, because I'm going to ask you to kind of predict. And I like to say everybody gets things wrong, but you only get the accolade. You get accolades if you only have to be correct once. So I'm hoping that you're correct in this one. But where do you see application security changes in the future? Where is all of these things going in terms of single sign-on, multi-factor authentication, cloud, SaaS, etc.? What's happening here?
A great question. I think we will see a move away from this. We mentioned it before. This perimeter model to accessing applications. I think there's going to be a move away from that towards your zero trust network access. I think this idea that we treat connections from the internet as I said, with one level of security, but someone who may be, just because they happen to be, within the office, that we say, okay, here's the keys to everything. I think that's going to change. So definitely more ZTNA approaches are going to be considered for all organizations. And then the way that's delivered will obviously depend on the use cases and what's required. I think when you look at the MFA providers, the cloud providers and so on, I think sometimes the question is, which one should we use? Or I don't even think that's the question. I think it's an ecosystem, and we need to just pick vendors and services that can feed into each other, so that can support your common protocols and so on, so that we can pick and choose the bits we want. So if I want an app that can provide a multi-factor pop-up for specific thick client accesses, I can do that. Or if I want to pull in my legacy apps, I'm using maybe AD, I migrate maybe to Azure AD, I want to pull in my legacy apps, I can easily do that. And it's just about looking for vendors that have that interoperability and so on.
That's awesome. And ZTNA, Zero Trust Network Access, it makes sense, and it ties into this, excuse me, it ties into the single sign-on Azure AD concept that we're talking about, because we want to get rid of these VPN border control points and things like that, because really and truly, ultimately, what we're trying to do is authenticate per application. And that sounds awful because now we have to do it every single time. But when you integrate that with multi-factor authentication and single sign-on, it becomes a very seamless, unified model, if I can start using these marketing terms, because now I authenticate, I get my credentials, and then I like to call it a ticket stub. So I have my receipt, my ticket stub to say I got authenticated. Now I go to my other applications, no matter where they exist in the world, cloud, on-prem, and I show this receipt to them, and they say, oh, you are already authenticated and you are allowed to access me and grant me access to the application. So it becomes a very nice, clean system for us to create. And yeah, that's kind of the one of the digital nirvanas we're trying to achieve in this world, right? With this IT architectures.
Yeah, and I'd even go a little bit further and say it's not even a receipt. It's almost like a magic receipt. It's a magic receipt that we can revoke whenever we want. And
exactly.
It probably feeds into the other part we didn't touch on, but the key to this single sign-on then is having the visibility and the logging. to actually see what's happening, having the controls in place that, when a user is suddenly jumping from one country to the other, accessing the same app, whether it be SaaS or on-site, it shouldn't matter. You as an organization should be able to say, hey, this isn't normal behavior, give them another challenge, or maybe, block that user until an administrator has approved them, whatever the appropriate response is.
Awesome. Yeah, those are great use cases on how we can take advantage of this technology. So I appreciate you, Barry, coming to us and sharing your knowledge, because you have passed on some great pieces of information for us. Thank you for your time. Thank you, everybody, for listening to this, and I hope to be talking with you sometime soon, Barry. Thank you very much.
Thank you, Frank. It's my pleasure.
Absolutely.
The session has now concluded. Make sure to download your handouts at petri.com/conferences or find the links down in the descriptions below. We'll have more sessions starting up here shortly.
Hello everyone, and welcome to Getting YAML Pipelines Up and Running in an Hour in Azure DevOps. My name is Ryan Irujo, and I'm a Principal Consultant at Interfactor, Norway. If you have any questions or comments after this presentation, feel free to contact me directly on LinkedIn, Twitter, or GitHub. Before you get started with this demonstration, you will need access to an Azure subscription and an Azure DevOps organization. If you do not have access to an Azure subscription, you can either sign up for a free version or activate a sandbox version, which is available for roughly 4 hours on Microsoft Learn using one of the Learning Path modules. I recommend choosing the Build and Deploy to Azure Static Web Apps exercise. From here, you can click on the Sign in to Activate Sandbox button, log in using your Microsoft account, whereby an Azure subscription will be provisioned for you. To set up an Azure DevOps organization and account, browse to azure.microsoft.com/services/DevOps and either sign in to your existing Azure DevOps account or click on the Start Free button and follow the wizard. Okay, now that we have our prerequisites out of the way, it's now time to set up a service connection to our Azure subscription. So flip back over to your Azure DevOps organization, create a new project. We're going to call ours YAML Pipelines Demo. You'll notice I already have this project in place. You can name your project whatever you'd like. Click on the project you've created. Browse down to Project Settings. Down in the bottom here, we're browsing to Service Connections. And we're going to create our first service connection to our Azure subscription. So click on Create Service Connection. We're going to use the Azure Resource Manager connection type. And we're automatically going to provision a service principal for this connection. We're going to scope it at the subscription level. If you are prompted to log into the Azure portal or to your Azure subscription, go ahead and do so when prompted. Authenticate to your subscription accordingly. And now we can give our service connection a name. We're going to name it after our demonstration, YAML Pipelines Demo. Leave the security to grant access permission all pipelines in place, and then click on Save. All right, and our service connection is now in place. If you browse to your Azure portal and you're wondering where the service principal can be seen or viewed, browse to App Registrations, refresh your view in here, and you'll notice we have a new service principal provisioned, and you'll see the app registration associated with it in here as well. If you decide at the end of this to delete the YAML Pipelines Demo service connection, it will automatically delete the service principal associated with the service connection. Now that we have our service connection to our Azure sub in place, it is now time for us to create a new Git repository. Flick back over to Azure DevOps, browse to your project, go under Project Settings, scroll down to Repositories, and then use the wizard above in the top right to create a new repository. You'll be naming your repository Pipeline-Demo. I already have this repository in use that I'll be using throughout the rest of the demo. All you need to do is click on Create, and the repo will be allocated for you. Now that we have our Git repository in place in Azure DevOps, now we can move on to creating our initial YAML pipeline build file in Azure DevOps. So from here, change back over to our project in Azure DevOps. And two things I'd like to note here. As we continue going forward, you'll notice that the browser window here has been zoomed in a bit to make it easier for you to read and view the code that is being given in this demonstration. Likewise, to be able to see better into the Azure portal for anything we are demonstrating in here as well. Additionally, throughout the rest of this demonstration, I'll be copying, pasting content into here and then explaining what is going on with the files that we're using. The content that is in here will be available online at the time of this presentation when it becomes available online, and therefore you'll be able to copy and paste like I'm doing here in this demonstration as well. So from here, under our pipeline-demo repo, up top, click and then click New and File. We're going to name our file pipeline.yaml. Going to paste in the following content and commit it. Now, let's go ahead and break down what's going on in this actual file. So first of all, you'll notice that whenever a pipeline is associated with this file here, any changes made to the main branch, formerly known as master branch, will trigger the pipeline for anything made into this Git repository. Secondly, the pipeline is using an Azure DevOps Linux agent to run any tasks or steps that are associated with this pipeline. In this case, we're using Ubuntu latest. That is right now Ubuntu 18.04. In the near future, that should be changed to Ubuntu 20.04. We're running a single task in here using Azure CLI, whereby we are deploying a resource group to our associated Azure subscription. Our Azure subscription is the one we created a service connection to, YAML-pipelines-demo. And the name you want to use in here should match the name of the service connection associated with the Azure subscription you are working with. We are running a bash script inline, and in here we're running az group create, and we're creating a resource group called YAML-pipeline-demo-rg. We're putting it in Western Europe, and the output of this script is going to be returned in logs in table format. Okay, now that our YAML pipeline build file is in place, it's time to create our Azure DevOps pipeline. So from here, flip back over to Azure DevOps. On the left-hand side under our project, click on Pipelines. Click on Create Pipeline. Choose Azure Repos Git. Choose our Git repo pipeline-demo. We're going to choose existing Azure Pipelines YAML file. We're going to select from the main branch, and we're going to select our pipeline.yaml file we created earlier. Click on Continue. From here, you can review the content of your pipeline YAML file, verify that everything is in place as you intended it to be. And when you're done, you have two options. You can either save the pipeline and run it later, or click on Run, at which point it will be saved and kick off the pipeline. Our single job is now in place and queued. We're going to browse to it, and it's waiting for an Azure DevOps Linux agent to be available and then provisioned to run the job. This deployment should take roughly 30 seconds to run because we're deploying a resource group. And as you can see, it has finished successfully. So we can quickly verify that by going to our deploying a resource group task, browsing to the bottom, and verifying that we see the name of our resource group YAML-pipeline-demo-rg has been deployed to Western Europe. Now let's go through some of the things that are going on here so we can match up what is going on with our pipeline as compared into our pipeline job. So the first thing you'll notice here is under Checkout Pipeline Demo. This is the point where the Linux agent is downloading the content of our Git repository. In this case, we have a single entry, pipeline.yaml. If you have any issues whereby you are concerned that there isn't something coming down or something may be not pulling correctly, or where you're wondering where things are being saved to in the Linux agent, you can come in here and review it in the Checkout Pipeline-demo to get a sense of what the agent is doing when it's pulling down the repo. If you want to verify the location of where things are working and running, it's usually easier to put commands in place in your task itself to see where your tasks are running from, either the location they are by running something like ls-l or pwd to find out where you are when the script is running in place or the task is running in place here. Just something to be aware of for the future. Now in the task itself here, we see that we are running Azure CLI in our task up above here. Below, you can verify which version we are running and any additional extensions that may be available at the time that this task is running. Below this, you'll have a section in here whereby the task is logging into the Azure subscription. It is using that using the YAML Pipelines demo service connection we created earlier. If you have any concerns that something is not working as intended, or you think you have a misconfiguration, you can come in here beneath the point where the service connection is logging in, and you can verify the ID and name of your Azure subscription. You'll notice in here that the credentials are all starred out to ensure that no information is leaked when the service connection is connecting to the Azure subscription in the task. After the authentication has taken place here, Azure CLI sets the subscription explicitly to the Azure sub you're working with, just in case you have more than one service principal associated with multiple subscriptions. This ensures you're targeting only what you should be working with. And in our case with the inline script, the contents of the inline script, this line right here, are copied and put into this file under home vsts work_temp, added into this file, and then ran. The results of that run are then displayed below. Once the results of that run are displayed, or if you have an error, that will appear here. When the task has finished completely, the Azure CLI will log itself out to ensure that no credentials are withstanding on the DevOps agent it ran from. Once it's finished running, you can browse back to the Azure portal, verify your resource group is deployed, browse to it quickly, and we see that it has been deployed successfully. Our resource group name to the correct subscription we were looking at earlier, and to the correct location. Okay, for our next section, we're going to discuss the difference between Azure, DevOps, Microsoft hosted versus self-hosted agents, and where and how and why you may want to use one or the other under certain circumstances. So flipping back over to our project, let's quickly go over where you can find hosted agents by Microsoft or your own self-hosted agents. So back under our project, we're going to browse under project settings, and we're going to scroll down to pipelines, agent pools. And in here, you will find any of the agent pools that you currently have running. The default agent pool for Microsoft hosted agents is known as Azure Pipelines. Underneath here, you will see the hosted agent itself, the last time it ran, its status, the version, agent version it is currently running, and whether it's enabled or not. Additional details about the agent are under the details section, and who has permission to manage the actual pipeline. We go back under our agent pools again. Every organization is built in with a default agent pool. There's nothing in here by default. Okay, you could add an Azure DevOps agent of your own into the default pool. It's not necessary. In our case, I've created an agent pool called YAML Pipeline Demo. I'll walk you through real quick how to do that, how to create it. Up top in the right-hand corner, click on Add Pool and determine what type of agent pool you're using, whether it's Azure Virtual Machine Scale Set or self-hosted. We're going to call ours self-hosted. We're going to name it YAML pipeline demo 2. You can provide a description whether you want to or not. You can determine what type of pipeline permissions you want it to have access to. We're going to say all, and then click on create. And from here, any self-hosted agents we want, we can deploy them and point them at this agent pool, whereby they'll be available to run pipeline related jobs. I'm going to delete this because we don't need this right now. Back under agent pools, the far right hand corner, look for the trash can next to the agent pool itself and click on delete. Okay, a little more information about why you would want to run a Microsoft versus a self-hosted agent. If you are running builds that you have no problem with their internet accessibility, whereby you are deciding that you can run them from wherever, you don't have any IP restrictions or anything. In most circumstances, you can use a Microsoft hosted agent. Not only is what is important about that is that the agent itself a lot of times can use different types of built-in URL hooks to actually run specific tasks, depending upon the pipeline task you're using. Therefore, if it needs some type of internet accessible resource to run your build, it's going to have access to that. Whereby if you are in an environment where you have internet restrictions that are essentially deny everything, allow only specific URLs or IP addresses, that's where you're more than likely going to be running a self-hosted Linux agent in that environment or a self-hosted Windows agent in said environment. It can be more intensive and time consuming in that type of environment, but by hosting it yourself, you can build your OS and configure the agent how you want it to run on the OS based upon the guidelines that you need to meet for your specific environment. Both of these links are available in the documentation that is included with this demonstration. Two sections in here I really recommend, irrespective if you're running a job that's focused more on a Linux platform or a Windows platform. The one section you want to pay attention to if you're running your own self-hosted agents and you want to automate their installation, you need to check out the unattended config section in here. Again, Linux or Windows. I'm going to go here under Linux. What this will allow you to do is that if you need to run the self-hosted Linux agent or Windows agent, the binaries that you need to run, you can pass all of the information you need to the binary in a script with switches so that you don't have to walk through this every single time manually. Highly recommend this if you're in a highly automated environment and you want to save a lot of time. Just spend the time to figure out how to get this to work in your specific environment, and then you don't have to worry about it ever again if you need to set up or redeploy a new agent for whatever reason. To get a hold of the actual agent, we can browse over here to get a hold of an agent for your specific platform, again, whether Windows or Linux. Click back over to our Azure DevOps environment, go to Agent Pools, click on the specific agent pool you want to work with, and then click on New Agent. From here, you have the ability to download the agent for your specific platform that you want it to run on and work with. And then you simply click on the download agent link under the specific platform. And you also can choose, x64 or x86 for your environment. For Linux, you can either run or download the binary for x64, ARM, ARM64, or RHEL 6. And now moving on to our next step, we're going to add an additional task to the YAML build pipeline file we created earlier. So changing back over to Azure DevOps, we're browsing to our pipeline-demo repository, back into pipeline.yaml, and in the Azure DevOps window here, we're going to edit our pipeline.yaml file and add an additional task. Please note that under normal circumstances, when you're dealing with a lot of infrastructure as code, if you want to ensure that your file types are being processed correctly and nothing is being interpreted incorrectly, use an actual IDE editor instead, such as Visual Studio Code. So from here, we're going to edit, and I'm going to add in a secondary task in here now. Our secondary tasks that we're adding here will deploy a storage account to the resource group we created earlier. We are again using the Azure subscription connection to run this particular task. Again, it's an inline bash script. And as you can see here, we're doing an AZ storage account create to create a storage account called YAML pipe demo str, deploying it in our resource group in the location of Western Europe. And as before, the output of this task should be returned in table format. Please note, since there may be more than one of you following this demo at a time, name your storage account something else. Add a few additional numbers, characters here at the end to ensure uniqueness. In this case, I'm just going to go with 0965, anything. I'm going to commit my change. I'm going to browse to my pipelines, and I'm opening it up in a separate tab. And you'll notice that our pipeline has been kicked off again because we just edited a file in our main branch. And now I'm going under our latest run, browsing to the job. And because Azure CLI is idempotent, the resource group will that we deployed earlier, Azure CLI will detect it, verify it's in place, and just conclude that it is in place and everything is fine. Same thing would happen with the storage account that we're deploying. The storage account is going to take a few additional seconds to run, but let's go ahead and review it. You already know, we already covered the information from earlier about the service connection. The information in here is identical to the service connection used for our resource group because it's the same service connection name. And here in our table output from our command for creating the storage account, we are presented with the tier, creation time, type of traffic allowed to the storage account. We can see the name of it's in place, the location, its primary location. In this case, our secondary location is Northern Europe, where it's being synced, and the resource group has been deployed to, and the status of our primary and secondary locations, or primary and secondary aspects of this storage account. So I'm going to browse over to the Azure portal, refresh the view, browse into our resource group, and there we go. Our storage account is now in place, working as intended. Okay, now moving on to our last and final section, we're going to cover your options available for preparing the pipeline for a production environment. So flipping back over to our Azure DevOps environment, I'm going back into our pipeline.yaml file. We're going to add in parameters to our existing pipeline file. The reason for adding parameters is so we can add some extensibility to our pipeline file and some additional reusability. We're going to start with a very simple sample that isn't going to do a lot in regards to making this pipeline more extensible, but we're going to build from there so we can show you how this could be used to make managing multiple pipelines or longer pipeline YAML files easier to manage for you. So I'm going to edit our file in place here. I'm going to add in a section below our pool here called parameters. And your parameters section can actually exist at the top of the file here. In a lot of cases, if you are parameterizing, for instance, your pool information in here, you would want your parameters to exist at the very top of this file. We're going to start with a parameter, or a section called parameters, sorry. First one we're going to call Azure subscription, and we're going to provide it with a value of YAML-pipelines-demo. And we're going to replace every section that we have in here that's using this current value with the parameter value instead, so that it is dynamically replaced at runtime. How we declare where a parameter should be used is we're going to use double quotes, which isn't necessarily required here. What is required is a $ followed by 2 opening curly braces, 2 closing curly braces, and in the section here, we need to specify parameters and then the name of our parameter. And it's important to have spaces, one space before your first opening curly brace or your second opening curly brace, and a space in between your first closing curly brace. We're going to copy this into our other input for Azure subscription. And then we're going to commit our change. And click on commit. I'm going to click over to our pipelines now. Refresh it, verify it is kicking off. And we see that our pipeline is running and working as intended so far. Now we're going to wait to verify that our tasks are going to run with the information passed via parameter. And there we go, working as intended. Working fine. You're not going to see any change in here in this particular case because, again, the Azure CLI tasks are idempotent. However, if we were to use the wrong name of the parameter in here or the wrong value for default, the task would fail because they'd be looking for a service connection name that doesn't exist in Azure DevOps. Okay, next, to extend upon what we just finished working on in here, we're going to edit our pipeline.yaml file again. Now we're going to parameterize some additional values in here. So I'm going to add a parameter for our resource group called RG name. I'm going to provide it a default value of YAML-pipeline-demo-rg. We're going to parameterize our Azure location. Give it the name of AZLock with a default value of West Europe. And finally, our storage account name, we're going to give it a default value of YAML pipe demo str. In this case here, because you already have a name value in here that is not, that you made unique earlier, you can copy this value, paste it in here, and make sure it matches. If you want to verify that a new storage account is going to be created after we're finished running this pipeline, just change the number here. And after we're done editing this pipeline and adding the additional parameters in here, you'll notice that we have a new storage account that's been created. So to make it easier to add in these additional parameters, we're just going to copy and paste our parameters at Azure subscription, and we're going to, for our first value, for the resource group name, we're just going to copy the RG name of our parameter and replace it where Azure subscription is for the name of the resource group. Since we know we have an additional resource group value we have to take care of, again, copy and paste the existing value in here. And paste it over resource group. So our resource group values are now in place. And you'll notice that when you highlight on specific values in the editor here, you'll be able to easily pinpoint where things are currently being used or if something looks like it's amiss. Next, we're going to replace our location, our static values, with our parameter values of AZLock. So again, I'm going to take an existing parameter definition in here, replace location, take the name AZLock and replace RG name with AZLock, and copy this over our location as well down here. All right, spacing appears to be in order. So the last parameter value we have to add in place is the name of our storage account. Now remember that since I am changing the default value of my storage account up here in parameters, you will see 965 in the Azure portal, as well as 966. This new storage account will be created after this pipeline is saved and triggers our pipeline to run. Okay, pasted the value in here. Let's take our str name for storage, paste in here, review that everything is correct. There's no missing double quotes, no missing curly braces or values. Everything appears to be in order. And now I'm going to commit it. I'm going to switch over to pipelines. Our pipeline is now kicked off. And now let's browse into our job and verify that this is going to work as intended. Resource group kicked off without a hitch. It's using the correct parameter value that we had previously. You'll notice that the storage account job is taking a little bit longer because the storage account does not exist yet that we're using. So it should be created and deployed successfully here in the next few seconds. And we can go ahead and review. It was successful for our storage account. And let's check the name of it. 0966. Everything has succeeded. Appears to be working as intended. And now let's browse over to the Azure portal, refresh. And there is our additional storage account that we created. All right, now that we've covered how to parameterize your pipeline file, we're going to extend this out a bit further to show you how we can deploy multiple Azure resources from a template in a build pipeline. In our particular case, we're going to demonstrate how you can deploy multiple resource groups and multiple storage accounts at the same time. Because of the complexity of this section, trying to type it out, I'm going to copy and paste the files that we need first, and then we will cover them in detail. So first off, I need to create a new file in here that I'm going to call deploy-resources.yaml. I'm going to paste in the content in here. And you'll notice that because I'm editing files in here at the same time, or adding new files in here, I'm going to end up triggering my pipeline. So one thing we should do right now, so that this doesn't get triggered until I'm done making my changes, I'm going to temporarily disable my pipeline. I'm going to go into here under settings and temporarily change it to disabled. We will enable this once we're done covering everything else, and we'll manually trigger our pipeline. Back to our GitHub repo here. Next, I'm going into my pipeline.yaml file, and I'm going to edit this file in place, and I'm going to paste in the following content, commit it, verify our pipeline is no longer running right now. Good, so everything is working as intended. So let's go over what's going on now. So we'll go with the smaller file first, pipeline.yaml. In this particular case, we are running a single stage here with a single job that is calling upon a template that we created just now, deploy-resources.yaml, and we are passing parameters to said template. Now, in order to pass multiple values, in this case multiple resource group names, we have each resource group name in double quotes separated by commas within square brackets, so that each of these values will be processed as it's being passed to the deploy-resources.yaml file. The other three parameter values we're passing are the service connection name, YAML-pipelines.-demo, which is parameter name is AZ sub. We're also passing our Azure location and the name of the environment that we are deploying to, which we're calling demo. If you want to see the name of the actual environment, you can go under pipelines, environments, and you can create the environment in here so that's associated with the environment that we're deploying to in here. Moving on to our deploy-resources.yaml file. It looks very similar to our previous tasks. In this case, we have a single job again, and under each job, under this job, we have a couple of steps, tasks, whereby we are creating our resource groups and our storage accounts. You'll notice that we are inheriting or passing in the parameters from our pipeline.yaml file, and we're using these values multiple times throughout. Now, in order to loop through each of the resource groups that we are processing here, we have this line here, which essentially means for each of the resource group names in our parameters that we have here in this array, process each name and then perform the following action for each resource group. In this particular case, you'll see we're passing in the resource group name. And please note that RG name here is not the same as RG names. It's referencing each individual name within the array in the parameter. And then after each resource group is processed, it completes as normal. You'll notice in here that we have our standard parameters that we're passing in earlier for our Azure subscription and our Azure location as well. For our second section in here for creating storage accounts, we're doing the same thing. We're processing each resource group name again. The difference being here is that in order to create our storage account names, I'm passing in the name of the resource group name. I'm ripping out all of the dashes because dashes can't exist in an Azure storage account name. And then I'm replacing the RG at the name of the resource group name, which you'll see here at the end of each resource group name in the pipeline.yaml file. And I'm replacing that value with str to represent storage. That value is then stored in this, or this value here is stored in a variable storage account name, which is then passed to the AZ storage account create command. The rest of the parameters you see here are standard that we discussed previously. Now that we have everything in place, we're going to go to our pipelines, and we need to edit our pipeline. Sorry, wrong screen. Let's go back into our pipeline again. We'll go into our pipeline demo settings. We need to enable it. Back to pipelines again. And we're going to run our pipeline, triggering the main branch. And our job is queued. I'm going to open this in a new tab and wait for it to be acquired by an Azure DevOps agent. This may only take a few seconds. Shouldn't be that bad. And there we go, it's kicked off. And you'll notice right away that we have, for each of our for each loops and our template, we are processing each resource group name and each storage account that needs to be created. So we'll see YAML pipeline demo RG, pipeline dev RG, pipeline test, and pipeline-prod. The same is being done for each of the storage accounts that is being created. Now to show you again the naming of the storage account, you'll see the name YAML pipeline demo str is named after the resource group name as we declared in our inline script. So you can see exactly where this naming convention is coming from. We see that these so far are succeeding. And the rest of these storage accounts should be deployed momentarily. Now, while you're running through this demonstration, if you want to ensure uniqueness, because other people may be running this demonstration as well, just change the name of your resource group names. Add numbers for demo, like a 4-digit numeric value for demo, 4-digit for dev, 4-digit for test, 4-digit for prod. That'll ensure uniqueness. Our pipeline has completed successfully. Our storage accounts and resource groups are in place. Now we need to go to our Azure portal, refresh our resource groups, and double check to verify that our storage accounts are now in place. And that concludes my presentation on YAML pipelines up and running in an hour in Azure DevOps. You can download the code from this presentation and additional resources at github.com/starkville/100 days of IAC. Thank you for your time and attention, and have a great day.
Hi and welcome everyone to this session about managing and govern your hybrid servers using Azure Arc. My name is Thomas Maurer. I'm a senior cloud advocate working at Microsoft, and this session we will go into how you can leverage the Azure control plane to manage your resources which are living outside of Azure using Azure Arc. Now, before we start, first a little bit about me. As I said, my name is Thomas Maurer. I work at Microsoft in the Azure engineering team as a cloud advocate. And what we are doing is basically creating content, delivering content, such as, for example, this presentation, but also speaking and listening to our customers and communities to learn what is working and what is not working, so we can then go back to the different feature teams within Azure Engineering and make our products and services better. Now, if you have any feedback for us, please feel free to reach out to us. You can connect to many of my different colleagues and obviously myself on social media or on our websites, and we can actually go into a discussion. We are always happy to learn from you. Now, before I joined Microsoft, I was a Microsoft MVP. I come heavily from the virtualization days with Hyper-V, then moved into Azure, obviously, and did a lot of Azure Stack work in the past. And I think almost 2 years now, I work at Microsoft. So in this session, again, as I said before, we're going to learn how you can leverage Azure to manage, on one hand, your on-premises environment and make your on-premises environment better using Azure. But then we also will have a look at how you can actually bring services to your on-prem environment, and also how you can take Azure Arc, not just to manage your servers, but also manage your Kubernetes clusters or your data services, like, for example, Microsoft SQL Server, and really take that advantage of our hybrid cloud offering. So I also promise you, I will have a lot of demos. I only have a couple of slides to explain you a little bit the concepts on what we are doing. And then most of actually the presentation will be demos, and I will show you how it works within the Azure portal and so on. Before we jump into that, we quickly want to obviously talk about why we're actually doing this and why we did develop Azure Arc and what the idea behind it is. So let me quickly talk about that. And when we started to look into this, we actually were looking at what is happening with our customer environments, like what are the challenges our customers are facing. And one thing we realized is that with all this new technology, with all the things going on, the customer environment gets usually increasingly complex, right? And I'm sure you realize that, and there are many reasons for that. And so we try to identify the main reasons for that happening. And so we have here, I will show you 3 reasons here. The first one being really that there are a lot of different apps. So if you're in the IT department, if you're an IT administrator or a developer, you usually manage tens or hundreds or even thousands of different applications. And some of these applications are very modern applications, written in modern languages like .NET Core. They're based on PaaS services, even serverless application, or they're containerized. But then we also have a lot of these traditional applications, right, which probably even more than we think, which run in virtual machines, and they run on even on physical machines. And again, but IT needs to take care of all of these, right, and manage all of these different types of applications. We also realized that a lot of our customers obviously have a very diverse infrastructure, right? They have their own data centers, they have branch offices, retail stores, factories, other edge locations. Then they also need to deal with different types of hardware. They have probably different OEMs on board, different server types, different storage types, and so on. And then even when it comes to even more modern environments, they also need to manage these IoT devices, right? So again, a big challenge for many IT departments out there to actually manage that. And then last but not least, we also see the concept of multi-cloud. And as you know, if you ever worked with a cloud provider, one cloud provider can already be pretty complex because of the huge tool set it offers. But if you add multiples of these in your environment, then you can imagine that it gets even more complex in that sense. And again, a lot of customers, you can see, they run into these multi-cloud environments. Some of them, the reason being that they already started with one of these cloud providers. And then they decided, for example, for Microsoft Azure as their main cloud provider, which is, by the way, an excellent choice. But now the departments which already deployed at other cloud providers, they're probably not going to move all these applications just over to Azure. No one wants to spend the budget for that and the time. Or in some cases, it's also just a strategic decision to have multiple cloud providers. Some customers like other services in different cloud providers better than others. So there are a lot of reasons why customers are doing that. But again, that obviously also adds a lot of complexity. So you can see, even with these 3 points, we already add a lot of complexity, or we already see a lot of complexity in our customer environments. So how can we address this, right? It's not just about the cloud moving everything to the cloud, but the cloud can also help us to make our on-premises environment even better. And so I took this picture back at Microsoft Ignite 2019. This is Jason Sanders. He is the engineering lead of all the Azure services, basically, directly under Scott Guthrie. And he did the second keynote directly after Satya, and he was talking a lot about hybrid. And I want to tell you basically one quote he did. He basically said that we can see, or we believe, that hybrid is an end state for our customers and not just an in-between state until everything is moved to the cloud. And I think that is very important because we see that, and so we are very serious about this to help our customers with their challenges, right? They can, in many cases, customers cannot just move everything to the cloud and everything is done. There are many reasons why customers also need to run services on premises or at the edge. And we are addressing this. Reasons, for example, being bad or no network connectivity at all, or some applications cannot handle with the latency. And then we also see, obviously, data sovereignty challenges, regulations, which, for example, forbid companies to store sensitive data outside of their own country. And then there are also some internal, for example, regulations or policies in place, which in some cases say, okay, you cannot store that without our four walls, right? And so customers have reasons why they want to be in a hybrid environment. And that makes absolutely fair sense. What we also see on this slide here is a short overview about our different offerings we have within Azure. And I will go into that deeper in just a bit to show you what we all have. But one thing I also want to mention is that we don't just have one solution for hybrid, right? I often get asked, so we now have Azure Arc, does that now replace Azure Stack or whatever? And I have to say, like, these are completely different use cases, right? You can combine it. Some customers probably need both. Some customer just needs one of these solutions. And not every customer has the same challenges. So we want to help addressing the different challenges our customers have with different services out there. And so that is why we obviously have that whole toolkit and that whole set in Azure. What also often gets forgotten is that we didn't just start hybrid with Azure Stack or Azure Arc. We had hybrid before, right? Azure had a lot of hybrid integration since it's built. It's basically designed to be hybrid. And we can see that in many of our services. If you think about our management services we have, you could already, for example, use Azure Update Management, Azure Automation. When it comes to security and identity, we obviously have Azure AD, Azure Security Center, Azure Sentinel. And also when you think about data services and DevOps, we already have these hybrid services in place. We sometimes did a great job to tell our customers that they are there, and you cannot just use them for Azure, but you can also use them to make your on-premises environment better. So this is all the things we see, and we obviously talk a lot about these, but let me quickly show you how our hybrid offering a little bit looks like. And again, there's a lot of things going on, and we have a lot of offerings again to tackle all these different challenges we see. Let's start on the bottom right. You can see here, obviously, we have a whole set of our Azure IoT services available for our customers who want to manage their IoT devices, who want to get that data from their IoT devices and actually analyze them with the power of the cloud to get all that data organized and analyze it using machine learning and AI to create their different models. Again, I could speak for hours about IoT, but obviously the focus of this presentation is more on other stuff. But again, it's a very important part that we have a large offering there as well. We also then have in the middle Azure Stack, our Azure Stack portfolio. Azure Stack is not just a single product anymore as in the beginning. It's now a set or a family or a portfolio of products with Azure Stack Edge, which is a first-party appliance to run, for example, AI and machine learning at the edge, but it's also kind of like a storage gateway for your data to Azure. Then we have Azure Stack Hub, which was the original Azure Stack, which allows you to run, for example, a cloud-consistent environment with Azure in a disconnected environment, for example. And then we also have the newly announced Azure Stack HCI. And that is our hyper-converged virtualization platform, which allows you to run virtual machines, Linux and Windows machines for very small deployments in branch office or at the edge with like very small 2-node clusters, but then scale it up to large high-performance cluster environments for your own data centers. And with all that flexibility with different OEMs, different solutions in there, and then connect that to the cloud, bringing additional services from Azure on top of like Azure Stack HCI. And then also allow you, for example, to run AKS, our Azure Kubernetes service, on top of Azure Stack HCI. And that brings me to the next thing. What we also see from customers a lot is they want to use our Azure services. However, as I mentioned before, there are reasons why they cannot use Azure, the Azure cloud environment to run so, right? So we have, for example, one customer came to us and told us, look, we love Azure SQL. We run a lot of Azure SQL, obviously, with all the applications we can. But we also have, in some locations, the problem that we can just not leverage an Azure data center there because you don't, like, your data center is too far away, so latency is too bad, or we're just not allowed to store data outside of that country. And so that is where they actually want to run Azure services within their data center on basically any infrastructure, right? So even if they have physical machines, if they have Hyper-V clusters, if they have VMware clusters, they want to run that. Or they can even run these services on top of other cloud providers, right? So if you like Azure SQL, but you run at another cloud provider, you can do that using part of Azure Arc. And the second part of Azure Arc is this line here in the middle, which is basically the single control plane our customers were asking for, right? We have now, with the cloud, we see customers using different tooling for their on-premise environment, for the cloud environment, for different cloud providers even. And so they need some tooling which helps them actually to bring that all together, to get that single point of view, to govern and manage their resources. And I'm going to talk mostly about this today. And I'm going to take servers, Linux and Windows servers as an example, but this is not just there to manage Linux and Windows servers. It's also about Kubernetes clusters or data services as well. So when we speak about that single control plane, as I mentioned, this is really there to manage your environment running on premises, in a multi-cloud environment, or even at the edge, right? And when I speak about management, we're talking about, for example, organizing and govern resources at scale. And again, we do that already in Azure, right? With Azure Resource Manager, we are able to do that, to manage a lot of Azure resources at scale. And our customers told us, like, why can we not just use that to actually for services which are running outside of Azure? And then also take that example of our developer cloud practices and bring these on-prem. And I'm going to talk a little bit about that, how that looks like a little bit later. And then we can also take advantage of all the security services we have in Azure, right? So we can take advantage, for example, Azure Security Center recommendations, not just for virtual machines running in Azure, but also for servers and Kubernetes clusters and SQL servers running outside of Azure, which is a great benefit. So instead of talking about all of that on slides, let me show you a quick demo. So here I am in the Azure portal. I'm on the all resources page, right? And you can see here all the Azure resources. And you can also realize that everything in Azure basically we create is a resource, right? From virtual machines to disk to even network adapters, network interfaces, security groups, route tables, public IP addresses, databases, web apps, even availability set. Everything is basically a resource or an object. And every resource is basically part of a resource group, a location, and a subscription. And we can also then have, for example, tags to even organize our resources even more. Now, again, our customers came back and said, hey, this is great. This really helps us to manage and govern our resources, right, in Azure. But I want to use that for resources which live outside of Azure. So let me show you that really, really quickly. I'm going to filter here, and instead of just showing you the Azure resources, I'm just going to limit this view to servers with Azure Arc. I already joined a couple of servers which are running on premises in my own data centers, which is basically underneath my desk, or even at other cloud providers. And then I also want to see my Azure virtual machines. And now you can see here, I can see them side by side, right? Here you can see I have my Azure VMs, but then I can also have here my servers, which I connected, which are running on premises using Azure Arc. And you can see here, they show up like an Azure resource. They also have a type. They also are a part of a resource group. They're also part of an Azure location. They're part of a Azure subscription, and I can even use tags to actually organize that. So what I can do right now is, for example, I want to list all my servers from a specific cost center in my company. So what I'm going to do here is I'm going to use tags which I already created, and I have a tag here for cost center. So I'm going to select that tag and add that filter, and I want to see all my resources which are in cost center 1001. Now with that, you can see here, now I can see both all the servers, which are now 2 in that specific cost center. One is an Azure machine, a Linux Azure machine, and the other one is a Linux server running on premises. But I joined that here, and I can see now all the resources in that cost center in a single place, right? This is already great. I mean, how many times you have talked, for example, I have talked to customers, ask them for a list of all their servers, and they told me, yeah, well, we can create one, but it takes us like 2-3 days or even longer. Now you get basically that single pane of glass where you can actually see all your resources. And again, this is not just limited to servers. This is also available, for example, for your Kubernetes clusters as well. Now you say, Thomas, okay, this is great. I mean, I get that view. I get now that I can see and organize that a little bit, but I hope there is more. And of course, there's more. So let me go to Azure Policy. And now, for those who don't know what Azure Policy is, Azure Policy allows us basically to configure the Azure environment, right? So the cloud offers a lot of speed and flexibility. So you can just go and create a virtual machine in a couple of seconds, right? And deploy that. And that is great for our IT pros and developers, and you want to give them access to that. However, you want to keep a little bit of control, right? You don't want every developer, IT pro going out and deploying one of our large MV2 series virtual machines with a couple of hundred cores and I think up to over 12 terabytes of memory, and they drain your credit card in like 3 seconds. You want to keep that control of your Azure environment. You also probably want to limit like things for naming conventions or in which Azure regions things can be deployed. So that is where Azure policy can come in. Now, what a lot of people don't know is there's also something called Azure guest configuration policy. And this is really for our virtual machines running in Azure. And this allows us to set certain policies and audit our virtual machines in Azure. So I'm quickly going to show you how that looks like. So I'm going to do a new assignment of a policy. And I will not just assign a policy, I will assign an initiative here, which initiative is just a set of multiple policies. And what I can do here, I can select the scope. I can select a management group, a subscription, a resource group, and even down to a resource. In this case, I just selected my subscription. And then I'm going to select an available policy or initiative here. So we give you a couple of built-in definitions and policies already, right? So you can see here, we have a couple of them in here. A lot of them are focused on industry certifications, for example. So if you were dealing with IRS certifications, we also have, obviously, for UK official, UK NHS, SWIFT, PCI, for example, a lot of stuff for government users in different cases where you have these things, ISO, and a lot of things of that. And that obviously is then a set of policies to actually go out and figure out, is my environment configured correctly, right? But what we also have here is simple ones, or very technical ones. For example, one I want to show you is this one here, which actually goes out and audits my servers, the operating system, for insecure password settings, right? So it has a look, we have a set of rules here, which it goes and checks and sees if everything is configured correctly, and then it will audit my machines and tell me which are not compliant. So like in a good cooking show, I already prepared this because it will take some time until I deployed it. It will go out and audit all these systems. But to show you that immediately, I'll just go back to policy and I can actually go into compliance view. Now in compliance view, I get an overview about how I am actually doing. And you can see here, I'm not doing so great. I still have a lot of potential to be more compliant in my environment. You can see here on the bottom the policies which are assigned, which I'm not compliant to. You can see here a lot of red, and then at one point you will also find hopefully some which policies I am compliant with. But I'm actually caring about one which I'm actually just showed you. Let's go with this one here, which again is the one I just showed you to audit my VMs for insecure password settings. So if you click on that, I obviously can figure out again that I'm not compliant with this. I can also see what is actually going on. If I scroll down, you can see here all the policies which are in this initiative. So all the different rules here to check. You can see here some of them I am compliant, some of them I'm not. But more interestingly, I can actually go out and see which resources are not compliant. And if I go in here now, what I can see here is I can see my Azure VMs, which are not compliant. You can see here the resource type Microsoft Compute Virtual Machine. But you can also see on the top here that it also goes out and checks my servers I joined using Azure Arc, my Microsoft.hybrid compute machines. So I can leverage the Azure guest configuration policies for my servers running on premises or even at other cloud providers, right? So that's a great thing here. So many of you now ask, Thomas, okay, how are we going to do that? Like what did you just show me? So what I want to show you here is a very high level architecture of Azure management. of the single control plane we are using here. And no worries, we will go through this. So let's start on the left side. So we as Azure customers, we are basically using tools like the portal, like PowerShell, the CLI, APIs, the SDKs, third-party tools to actually interact with Azure. And when we do that, we interact with Azure Resource Manager. That is actually the magic behind all the things I just showed you, like the role-based access control. So I can only access the resources I should have access to. About logs, subscription management, policies, blueprints, indexing, grouping, tagging, search, and even like deployment stuff, right? On top of that, we also have additional management services for containers, like monitoring, update management, backup, and security. And until we announced Azure Arc, a lot of these services were basically, and Azure Resource Manager were basically available for Azure services, right? So we could actually manage Azure VMs, we could manage web apps, Service Fabric, Kubernetes clusters, and others of our over 200 different services we have in Azure. Now, what we are doing with Azure Arc, we are basically extending Azure Resource Manager to allow us to connect resources which are outside of Azure. For example, servers, Kubernetes clusters, or data services, and so on, right? So these are just a couple of resources we just named, which are currently general available or in public preview, right? So this then allows us to take advantage of Azure Resource Manager and many of the management services we have in Azure. And then we can still use our local tools, right? We don't want to create that dependency to Azure, which then says, okay, if we don't have internet connectivity or connectivity to Azure anymore, everything fails. No, that is not what it is about, right? It should give you that additional management space, but you can still leverage your local server admin tools you're using, your native Kubernetes tools or Azure Data Studio to do complete local management of these resources. And so that is one part we can do. Now, I showed you how you can actually manage now a little bit of your servers, how they show up in Azure Resource Manager, how they show up in the portal. But let's have a look how actually the onboarding experience works and what more I can do with Azure Arc. So here I am back in the Azure portal. And if I want to onboard machines or Kubernetes clusters or use anything in Azure Arc also to manage, I can also go and search here, for example, for Azure Arc. And this will then show me the Azure Arc service here. And if I go to that, I get into the Azure Arc Center. So this is where I get all of the management for Azure Arc resources, right? You get here some additional overview. You get some like infrastructure overview. You can see here I can join different like server systems, Kubernetes clusters, SQL servers, and so on. You can also see that I can work with different data services here, for example, to create SQL managed instances which are running outside of Azure, or Postgres Hyperscale, which runs outside of Azure. You can also find additional information here. You can see here that I can manage my servers, my Kubernetes clusters, my SQL servers, and also Azure Stack HCI. Azure Stack HCI has Azure Arc built in. So when you deploy it and you register it with Azure, Azure Arc connects up to these resources. Now, for all the others, like servers and Kubernetes clusters and SQL servers and so on, we actually have an agent which we need to deploy on that server or on that cluster, which then connects up to Azure, right? And I will show you a bit how that looks like. If you want to know, by the way, about pricing, we also have here a direct link to pricing. And actually, we'll talk about that a little bit later, but you will be surprised how that looks like. So if we, for example, want to manage servers, we could do that again in the all resources blade. They show up, or we can just click here on servers, and then all the servers are already joined. They show up here. You can see some of them are connected and working. Some of them are offline, and some of them are expired because probably like I removed them or have to check what's going on with that server. But you can see here again, they look like Azure resources. Now, how do I join a server in this? So what I can do here is I can click on the add button here. And again, as I said, we actually need to deploy an agent. Now, you can obviously go out and read the documentation, download the agent, and run everything by yourself. However, we wanted to make it simple for you. So we give you these two wizards, basically, or these two options directly within the portal. One of them is actually creating an interactive script, which you can then copy or download and run on the specific machine. This will then download the agent, install the agent, and then register it with your Azure tenant. Now, with the interactive script, you actually need to log in with your Azure credentials while you run the script. So you definitely don't want to do that if you want to onboard a lot of different systems. So we also have an option where you can actually use a service principal name to actually onboard Azure Arc services. So there's a minimum permission, which only allows you to add servers to Azure, and it does not have any or more permissions as well. So you can then easily run that script to onboard hundreds, if not thousands of servers in just a couple of minutes. Now, for this demo, we're going to have a look how we generate that script in the interactive version. So if we start that wizard, this will help us a little bit figuring out what we need. And you can see here, we have some requirements here. It actually needs port 443 outgoing traffic to some Azure endpoints, right? Often people say it needs internet access. It's basically limited internet access because it only needs to obviously connect with some Azure endpoints here, and you can find that in the documentation. So if you're in an enterprise environment, you can easily use that. You also need obviously local administrator permissions to install the specific agent. And then in Azure, the only thing which we already need is a existing resource group to join these servers. So in the next step, we're actually going to configure that, define the script. So what we're going to choose is we're going to choose the subscription we want to join that server to. We're going to select the resource group where we want to join that server to. So I already created one here for our Azure Arc servers. And then we also join it to a Azure region. Now, this is only where, like, basically the closest region where the Azure Arc agent or the Azure Connected Machine agent connects to, right? So you can see here, not all regions show up. However, no data gets transferred except for metadata, which actually is like server names and data and stuff like that, where for the management part. So in my case, my server is closest to West Europe. And then I'm going to select, okay, is this a Windows or Linux server I'm going to join? In my case, this is now a Windows server. Obviously, we would then get a PowerShell script to run on that machine. If we would choose Linux, we would get a shell script to run on the Linux server. We can also configure a proxy server. And then we can already add some of the tags I just showed you. Like I showed you the cost center tag I created, but we can obviously add already a couple of other things like physical locations, like data center tag, city, or country, and so on, which help you to make it easier to manage your resources. Now, in my case, I also don't want to add custom tags right now, so I can just leave this open, and I can go out and add tags later on to all my machines if I want that. On the next side, I get then finally the script. So in this script, I get some information. I can just copy paste that, or I can download it. And what it actually does, again, you can see here there are 3 commands. So the first one goes out and downloads the agent installer, which in the Windows world is a MSI file. It installs that MSI package, so it installs the agent, and then it runs a command, which then basically registers my server to the specific Azure tenant, subscription, resource group, and gives all the additional information I just provided. So this is something I did, and then the server shows up after a couple of minutes, shows up here. If you're running Windows Admin Center, you also have the option in the settings in Windows Admin Center to actually do the exact same things without connecting to the Azure environment. You just go in. Windows Admin Center gives you the wizard, and you can actually run through this. Now, what can we do now with these servers as soon as they're joined? So let's have a look at this server here. The first thing we can realize when we go to that server, it looks like an Azure resource, right? If you look at the menu here, you can see here we have an overview, we have the activity log, we have role-based access control. So again, you can basically use Azure to do the role-based access control. So if you have, for example, SharePoint servers, or other application servers, you can make sure that only the SharePoint team can see these servers, or the SharePoint team only can see these servers, right? You can use tags as I showed you before. You can also see here all the information that it's joined to a resource group, to a subscription, and on the right side you also get some additional information. So you get, for example, the computer name. You can also see that this is actually a domain joined server to a local domain here. You get the operating system information and so on. Now, furthermore, we get obviously a couple of settings here. So the first thing I want to show you here is extensions. So if you have worked with Azure VMs before, you know that we have something called VM extensions, and you can actually deploy these. And so we also can deploy these on Azure Arc enabled servers. So this automatically detects that this is a Windows machine, so it only shows me the Windows extensions here. So we have a custom script extensions, which allows you to run a custom script against that server. You can run PowerShell desired state configuration against it, or you can directly use that to install the log analytics agent or the Azure monitoring agent, which then provides you with some additional management capabilities. Now, in this case, I already have done that. So I already onboarded that to the Azure Log Analytics part. So this also then allows me, for example, to use the security recommendations. So you can see here, I have a couple of security recommendations for that specific system that are coming directly out of Azure Security Center. And so I get here some information that, for example, I should probably install the updates on my machine. And it also gives me here, like, what is it, high, medium, or low. Now, importantly, I showed you this, you can do that out of the portal, but obviously you can also reuse ARM templates, also Azure Resource Manager templates, or CLI or PowerShell commands to actually run that. Now, with that, you get some additional management capabilities. So the first thing I want to show you is obviously that machine is now connected to Log Analytics. So I can actually access the logs which were sent to Azure. And you probably say, Thomas, this is something we saw before, right? We could do that before. We could install the Log Analytics agent manually and have all that. And yes, absolutely. But what you didn't have before is the role-based access control for that. Now, so in the past, what you need to do is give everyone access to the Log Analytics workspace. And so you saw all the logs from all the different servers, right? But now with Azure Arc, you actually can select the scope here, or you have to find the scope to only run that against this server. So like a SharePoint admin, he can only run log queries against this. So here in the middle, we can run log queries. Those are basically the same we did with Azure Log Analytics. It's using the keyword query language, or many of you also know it as Custo. So you can here run then our queries. So I have a very simple one here, which actually just gives me the update summary here, information, where I can see here, for example, how many updates are available, what updates are available, and so on. I can obviously also extend that. So you can see here I have many other logs here. I have performance logs available, security logs, I get system logs, whatever I actually enable, I can find here. Now with that, I can also start using Azure Monitoring. And with Azure Monitoring, the first thing I want to show you here is, for example, the performance monitoring part. So I can see how much disk space is used. I can see how the CPU utilization is, the memory utilization. You can see that this server doesn't really do much. And then you can also see how the IOPS on these systems are going, how the disk throughput is, disk latency. You also get some more information about, for example, network bandwidth and network throughput with data received and data sent and so on. And you get a lot of more information as well. But something I find really cool is the map view. So I get a dependency map. So let me show you that in a bit. I zoom out here a little bit first so you can see how the concept is. So I have my server here and I can see to which different endpoint that is connecting. So if I zoom back in here, you can see here one of the endpoints on port. You can see that one of the ports here my server is connecting to is 443 and it connects to 10 different endpoints. So I want to see the endpoints this server is connecting to. And you can see here all the different endpoints that server is connecting to. You can also see that we have here, that is the Azure Arc agent actually connecting to the Azure Arc endpoint. Now I can also, I'm not just seeing that for outgoing internet traffic. I can also see that if I go, for example, here, I can see port 135. And you can see here that this then goes to the local domain controller. So I know that this server somehow communicates with that specific server within my network. So very quick, very big benefit, really quickly done. Now, there is obviously more. I want to show you quickly policies. So I showed you policies before in terms of a policy administrator. I was able to like see all the policies in my environment and see all the resources which are not compliant or which are compliant. Now in this case, I only see the policies assigned to that specific server. So if I'm the server admin, I can now see, okay, which policies I'm compliant with and which I'm not. And then, for example, have a look at how that looks like. So in my case, I also have a policy here which checks if my server is in the right time zone, and you can see here that I'm not compliant. So this server does not necessarily be in the right time zone. So I could now go out and change that to be actually compliant with that. I also have the create remediation task here. So I can also do for some policies, I can actually go out and create that task and it will fix it for me. We also have then different tools. Using, for example, inventory. So we get a software inventory of that specific server. Also very handy. So if we want to have a look if something is installed on that machine, we can see here that this server has Edge installed. This also obviously works with Windows services, Windows registry and files and so on, if I configure that. And then I can also have a look at change tracking to figure out what changes on that server. Now I can see what changes, when are the changes happening. So I can see if there are a lot of changes happening, I can see that. And then I can see what is actually happening. So here, for example, we have some changes on services, probably some services which just are restarted to do some checks. For example, sometimes updates checks and so on. But then here, for example, we have some additional software installed, which is actually a security update for Microsoft Defender antivirus. So this shows up here as well. So this is very handy if you want to see what's going on. We also have update management. Now, this is one of the great tools we have. We all know the challenges with updating machines. We have usually multiple tools because we have Linux and Windows servers. We have running them on premises and in the cloud and different cloud providers. So we end up with a big bunch of different tools. And so this is where Azure Update Management can come in. It can actually manage updates for Windows and Linux servers running on premises in Azure or even at other cloud providers. And that gave you that single control plane. So what I can see here first, I can see here the updates, the missing updates on that specific server. So you can see here that I have security updates missing, which I should probably fix. That's why I'm not compliant. So what I can do here now is I can schedule a new update deployment. So I can give that a name. This is now just for this single server. However, I will show you in a bit how you can also do that for a group of servers in just a bit. It also automatically has detected that this is a Windows server. I can define the length of the maintenance window, and then I can say, okay, should I reboot the server? I can say, okay, only reboot. So if I just want to reboot the server, that's also a good trick to do. I can always reboot, never reboot, or reboot if the updates like I installed require a reboot. So that is usually a good option. And then I can go out and schedule it. Now I can say update now, which would happen in like the next 5 to 10 minutes. But since I'm in the middle of a demo here, it's probably not the right thing to do. Also for many of you who actually run a business critical environment, you probably don't want to do that during business hours. So what you can do is you can actually go out and schedule it to a specific time, like out of the business hours, for example. And then to make it even more manageable, you can even create a recurring update deployment. So you can say, hey, every week on Tuesday night, I want, for example, to install updates for that specific server. So I can do that. I can then go forward and then go a little bit more and come into configuration. So I can select the specific classifications of updates I want to install. So if I, for example, only want to install security updates, I can do that as well. I can include and exclude updates. I can even run a script, pre and a post script if I need to. And at the end, I can review that and actually create that update deployment. Now, again, pretty great to actually update the server, but now many of you will ask me, Thomas, yeah, but I have hundreds or even more of servers to manage. I don't want to do that like for every single server. And you're absolutely right. Since update management and all these management services are not something new with Azure Arc, they're already existing for a while. They're part of Azure Automation and Log Analytics. So we can just simply go to manage multiple machines here. And this will automatically take me here to my Azure Automation account. And you can see here that also change tracking and inventory are part of this. And what you can now see here is you can see here all my servers which are joined to that specific update management solution. And you can see here this can be Windows and Linux servers. These can be also non-Azure machines and Azure machines. And what I can do here now is I could go out and schedule an update deployment. And here I could select or create a group of servers I want to update. So I can also do very smart things, like I can take advantage of tags in Azure. I can tag, what we have done with other customers before is we created a tag called update group. And then you had, for example, 2 update groups. One update group, the update group 1 was running the updates on Tuesday night, and update group 2 was running the updates on Thursday night. So if you had 2 controllers, you actually put them in use 2 different tags. So one domain controller would update on Tuesday nights and the second domain controller would update on Thursday night. And then that would basically create dynamic groups. So you don't need to change the groups all the time. You can just change the tags on the servers. So that is pretty cool feature of Azure Arc and Azure Management. And I hope I could give you a little bit of an overview of the single control plane here. I also want to quickly go back to the Azure Arc environment. So we also have other services here like Kubernetes clusters. So I can show you here, not just servers, but also my Kubernetes clusters. If I go and have a look at one of these clusters, I can see here, again, it looks like an Azure resource. It looks like a Kubernetes cluster I could run in Azure. So I also get some alerting, logs, and monitoring. So if I have a look at monitoring, you can actually see what my Kubernetes cluster running outside of Azure is doing. So you can see here the node CPU utilization, the node memory utilization, the node count in general, and so on. I can even go deeper into the nodes, for example, and see what's happening there. I can go deeper, drill into this to actually find the different information here as well. I can even go down and have a look at all the containers running on that Kubernetes cluster. So let me open that up a little bit. So you can see here, if I'm going in, I can find the different information for these clusters. And apologize for the view, just since I'm making everything a little bit bigger, so people can actually see what's going on. You can get a better overview on your own desk then. But you can see here then all the containers and how they're doing and how they're running and how long their uptime is and so on. So let's switch back to the slides. And I want to show you some of the key takeaways of Azure Arc enabled servers I just showed you. To summarize this a little bit, it enables you to provide you with inventory. So you can actually add Windows and Linux servers, physical and virtual machines, running in your private data center, at the edge, or at other cloud providers. And it's completely domain agnostic. We can then take advantage of governance and security tools from Azure. So we can take advantage of, for example, Azure Policy, Azure Guest Configuration Policy. We can take advantage of Azure Security Center for the security baselines and so on to see actually are our resources configured compliant and securely. We can also access that using role-based access, or take advantage of role-based access control. So you obviously get that view, like with your centralized IT, you get that great overview about all your systems, but you can also enable different application groups and application admins to have access to these servers and workloads. You can also take advantage, if you're a managed service provider and you're working with Azure Lighthouse, to manage different customers and customer environments and different customer tenants. Azure Arc also works with that, so you can also leverage that as well. And then obviously the first things I showed you is like you get that searchable inventory, you get that consistent management experience, for example, through the portal, but also through other tools. And then you can organize your resources, for example, using tags, and take advantage of that as well. Now, I only showed you a little bit of Azure Arc. There's much more we could talk about, and I just want to highlight a couple of these things and make a step back to actually what Azure Arc can do as well. So I was showing you the organizing and govern part in your environment, especially on the server side. But however, that also works obviously with Kubernetes clusters. So you can also make sure that your Kubernetes clusters are configured securely using Azure policy, for example, check the compliance states of these Kubernetes clusters at scale as well, not just for your servers. And then we can also enable something for app management for your Kubernetes clusters as well. So we can configure something with a concept called GitOps, where we actually check in the application code and the application configuration of your containerized application into a Git repository. And then the Kubernetes clusters running on-prem or at another cloud provider, they can automatically get that information and check that Git repository for any changes, and then actually do these changes through the applications or running on that Kubernetes cluster. So very powerful way. If you need to manage, for example, multiple Kubernetes clusters with different applications, you can configure that very easily and use these DevOps techniques for that. And then I spoke about that as well. Azure Arc also enables you to run Azure data services anywhere. So you can actually go out and deploy Azure SQL managed instances, for example, in your own data center using Azure Arc. And again, there's much more to that as well. What I also want to quickly say is at the moment, we have Azure Arc enabled servers, which is generally available, so you get full support for that. Kubernetes and data services are currently in preview, so you're just going to check it out, but don't use it in production, but you can actually go out and test it. And the good thing about these two things right now, because they're in preview, they're actually free of charge. Now, for the server part, joining servers to Azure Arc is actually free. So you get some base services which are free, and then you have some extended services. So as soon as you, for example, start using Azure Security Center, Log Analytics, and all this stuff, or Azure Policy, then you pay for these specific additional services. But if you want to try it out and just see, like, get the inventory, get the power of that single control plane, you can actually go out and try that out now. And again, there's good documentation on how the pricing actually works, but don't expect any crazy pricing on that side. I know that we have a very technical audience, so I also want to quickly give you an overview about the Azure Arc architecture in general. And it's kind of like similar on what you showed before, but again, we start on the left side. So if you manage Azure resources, we are actually using tools like the portal, the CLI, PowerShell, the SDKs, and so on. And then we interact with Azure Resource Manager, which provides us with all these management technologies. Now in blue, you can see everything specific to Azure Arc. And usually what we have is we have resource providers, which are plugged into Azure Resource Manager. Basically every server has at least one resource provider. And then you can see here, for example, at the bottom, the Azure Arc server resource provider connects to the Azure Arc agent connects to the Azure Arc resource provider. For the server side, the same thing happens on Kubernetes clusters. And then for the data services part, the same thing. But what you also can see here is that the requirements to run Azure data services like Azure SQL or Postgres, what you need is a Kubernetes cluster, right? So all you need to deploy Azure SQL is actually a Kubernetes cluster. And again, for all of these services, you can still use your own local tools, for example, you're using for server administration, Kubernetes administration, and so on. So I want to do another step back and actually mention that, again, Azure Arc is just one of our hybrid offerings. It is basically the piece which extends Azure Resource Manager and allows you to connect up these services. But again, we have also a lot of other stuff like the whole Azure IoT offering, and then our Azure Stack portfolio with Azure Stack Hub, Azure Stack Edge, and Azure Stack HCI. And then obviously bring that together with management, security, identity, and many others. And a lot of customers now asking, okay, when do I use what? It obviously really depends on what your what your needs are, right? So depending, some customers, they probably need Azure Stack, some customers need IoT, some of them need Azure Arc, or you need even like two and combine them, or all of them, really depending on what you have. So for example, you could actually go out and deploy an Azure Stack Hub environment, put the Azure Kubernetes engine on top of that, so you have a Kubernetes cluster, which you then can connect up to Azure for the management part using Azure Arc. So there's many things you can connect here. And again, we don't just have one solution which fits every customer or should fit every customer. We really try to go out and help the customers with their specific needs. So with that, I want to say thank you very much for listening to me. If you have any questions, please reach out. Thank you again.
This session has now concluded. Make sure to download your handouts at petri.com/conferences or find the links down in the descriptions below. We'll have more sessions starting up here shortly.
The load balancer's privileged position in the network means it's ideally situated to power always-on application experience, AX, ensuring resilience and total flexibility wherever applications are deployed and wherever you are working from, home or office. Kemp load balancers are available as a virtual, hardware, cloud, or bare metal load balancer, offering hundreds of features, supporting thousands of applications, including the collaboration and meeting apps used by today's remote workforce. Application templates for all major workloads simplify deployment and guarantee best practice delivery. Load balancing across public clouds, including Azure and AWS. Deployed on all major hypervisors to deliver the intelligent workspaces and desktop virtualization that boost collaboration and replicate in-office environments. Customers in 115 countries with over 100,000 deployments, all depending on one application experience expert, Kemp. More simplified deployments, more flexible licensing options, world-class direct technical support, unmatched value and cost savings. Take control of your application experience at kemp.ax.
Hi everybody, and thank you for spending some time with me today while I take you through my session of how to tackle a data center migration to the cloud. My name is Sarah Lean and I'm a Senior Cloud Advocate at Microsoft. I've been in the IT industry for well over 14 years now, and in my previous job before joining Microsoft, I was an infrastructure engineer, or an IT pro if you want to use that phrase, and that's how I tackle a lot of technology projects. Now my contact details are on screen, so please do reach out to me if you have any feedback or questions relating to this session. I'd be happy to answer them. Now, a data center transformation project or a migration project can often be quite daunting for a lot of organizations. You'll see from this diagram that it can be a twisty-turny type of project where lots of things change and there's lots of important milestones along the way. However, lots of companies embark on these projects and find that they are quite advantageous once they complete them. It can really drive innovation within the business and the IT department on completion. Now, regardless of how you start this project, there are a few things to think about when you're doing them. And lots of organisations have been triggered into doing these projects because of industry standards or events happening within their organisation or things happening out with of their organisation as well. I've spoke to customers who are looking to migrate to the cloud because they physically do not have enough space within their current data center in order to add on additional resources and workloads, and they're looking to expand up into the cloud and actually take this opportunity to take the rest of their workloads and move them into the cloud with those newer workloads as well. Also, legacy hardware, legacy software is also driving innovation. It's time to upgrade, it's time to get rid of that older hardware that's no longer supported and parts are hard to find. And again, they don't want to be running insecure or unsupported operating systems. So again, they're looking at this as a time to change and move their data center as well as upgrading everything. And obviously 2020 has thrown us all for a loop, and lots of organisations have had to adapt on how they work as well, and remote working has become a big thing for everybody, and lots of organisations are using the cloud to help provide the resources that people need in order to work remotely and are no longer working in offices. However, regardless of why you're migrating, the size of your organisation or the industry that you're actually in, I always believe there's 4 key stages that you need to complete within this project, and this is what we're going to be concentrating on today. And I'm going to be sharing some of the tips and tricks that I've collected over the years talking to customers so that you can address them when you're embarking in your own data centre transformation project. Now, those 4 stages, I believe, are discovery, assessment, migrate, and secure and manage. Now, arguably, people will say that the secure and manage stage is actually sprinkled throughout your project, as well as being its own separate stage, but we'll get to that later in the presentation. Before we jump into the stages though, I want to highlight how you can be successful in this project, because people often think that a data center transformation is all about the technology. And arguably it is about the technology. That's what you're moving, that's what you're redesigning, that's what you're re-architecting. However, there's a key component to that project as well, and that's people. People are very much included in this project, and you need to make sure that you're taking them on the journey with you. When I talk about people, I'm talking about your end users, your business stakeholders, and the people within your IT department. If you exclude them from this process, this journey that you're on as an organisation, then your project is not going to be successful. You're going to hit more hurdles than you need to. Whereas if you include them, then it will be successful. So think about the technology and the people when you're embarking on this journey. And we'll be talking about how you can incorporate that into the different project stages as I go throughout my presentation. Now, the other thing to think about when you're embarking on this project is to think about what success actually means for your organisation. When will the project be successful? When will it be marked as a failure? And when will it be marked as complete as well? Now, if your migration trigger is something like your data center lease is running out and you want to be out before that lease runs out, then your success metric is probably going to be very simple. It's going to be out of the data center before the lease runs out. However, if your data center trigger is something else, then you have to make sure that you have that success metric so that you know when the project is finished, you know when the CEO is going to come to you and give you a good hearty handshake or pat on the back for completing it successfully. Make sure you're defining that along your journey as well, because without that, projects can often flail and go in the wrong direction without that appropriate success metric constantly at the forefront. Now on to the project stages. Now the first one is discovery, and arguably I always say that this is the most important stage along your project journey. This can make or break for me your project success. If you skip this stage, which I've seen unfortunately some customers do, it can often burden you along the journey and make things 10 times harder for you further on in the project. Now in the discovery phase, we do want to focus on the technology. You should know your environment, you should know all of your workloads and how they all hang together, but unfortunately there's probably going to be something when you discover and do some deep dive digging into your technology that there is something that has been put in temporarily and is now production and has now been running for several years without having that official label of production. And when you look at your technology, you should be thinking about how it all works together, because 9 times out of 10 your servers will not just work independently. They'll not work on an individual silo. They will interconnect with something and some other workload within your environment, even if that is just your Active Directory server for authentication as well. So you need to understand all those dependencies and how everything within your environment is interlinked and works together, so that you can help pair them up and think about them as groups of servers rather than individual servers when you start to redesign or move them up into the cloud. There's also things that you should be thinking about in terms of vendor support. If you're running a third-party application, which many of you will, on top of those servers, look into your support agreements and speak to these vendors about whether they are happy to support your workload in the cloud. There are some software vendors that don't support workloads being in the cloud at all, or in certain states, so they might not support it the way that you would like to put it into the cloud. So make sure you're speaking and opening up those communication channels to your third-party vendors and including them along this journey with you. You should also be thinking about things like the criticality of your workloads. Is it mission critical to the business? Is it not mission critical to the business? Will that redefine how you actually host and run that workload within the cloud? Is it time to readdress that criticality for a certain workload? There's lots of change points that could be happening along here, so make sure you're asking these questions and finding out the answers. And alongside that, you should be thinking about backup and disaster recovery and what your control mechanisms for that are going to be. Again, how often does it need backed up? Is there actually a disaster recovery plan that needs implemented for this? And start to question all of these things and start to gather that information around what's happening within your environment. Now, I'm not suggesting that you go out and maybe just use a bit of paper and a bit of pen and maybe a rudimental PowerShell script to find this information. There are tools out there that can help you gather this information and put it into a nice readable format for you to go out and use. And at Microsoft, we have a tool called the Azure Migrate server assessment tool that can help you gather some of that information. But you should be looking at all the spectrum of tools that are available. They all kind of collect the same information available to you that you want for your discovery phase, but some of them do it in different ways. You should be looking at how they collect that information. Do they need an agent installed within every server to collect that information, or do they need an account and ports opened within your network? And where do they store that information once it's collected? Is it stored locally on a server somewhere, or is it pushed up to the cloud for analysis? And how much does that tool actually cost? And depending on your needs, your project budget, and how your organisation is set up and your appetite for installing these third-party tools, that will help decide which tool is more appropriate for you. So interrogate what these tools do, investigate what they do, and find the right one for your organisation to help you gather all of that information about your servers and your workloads for later analysis. Now, the other thing you should be doing within your discovery is talking to your end users, talking to the business owner of workloads. And a prime example of this is, say, your payroll application. Find out who uses it, who owns it within the business, and speak to them about the life cycle of that application and that workload. Do they like it? Is it coming to end of life because they've been having conversations with vendors about even replacing it, and haven't included the IT department? It won't be the first time that people have went off and bought software without including the IT department. Speak to them about any usage, when they can suffer outages. Obviously, if it's your payroll application, they don't want to be having an outage or the application being moved during the payroll run. Everybody wants to be paid and no one wants to be the person that's causing that not to happen. So interrogate them, ask them these questions, and open up those communication lines. Start to talk to them about your plans, your needs, and ask them what their plans are and their needs as well, and feed that back into your analysis so that you can later design what's happening with that workload going forward in the cloud. Now, you should also be talking to the people within the IT department, talking to them about whether they need additional training and whether they're skilled up on how to use the cloud platform, hopefully Microsoft Azure, that you're moving to. And that's the short-term plan, so you need to be able to skill them up quickly in order to facilitate this migration project. And then you have to think about the long-term plan. Gone are the days of sending your IT staff out to a week-long intensive course where they get to know that operating system or piece of software, and then they're trained up for 3 or 5 years until that new operating system or a new version of the software comes out. You constantly have to be learning with the cloud, and you constantly have to be thinking about how you can support people learning those new things so that they can drive innovation and keep up to date with best practices, changes, any new features, depreciation of features. And this is where you start to talk to them and understand their needs. How does people within your environment and your organisation learn? Do they like hands-on learning? Should you support them with some Azure credits to play and have a hands-on kind of lab experience with the platform? Or do they prefer to go on training courses and you need to support them there? So there's 2 things you should be thinking about here: gathering information about what training your staff need in order to support the migration short term, and also thinking about what the long-term plans for training your IT staff look like as well. Now, another thing you should be thinking about within your discovery phase is costings. Understanding what it currently costs you to run your IT department on-prem, and then looking towards the cloud cost as well. Now, when you're looking at your existing costs, please do look out with of just running the hardware and how much the hardware and the software costs you. When you are looking at the cloud costs, those cloud costs include things like physical security, hardware refreshes, and various other different components, as well as the hardware and the software that you're running. And if you're not comparing your existing costs, including those things, with the cloud costs, you're going to be comparing 2 very different things and get a very different outcome. So think about what your existing costs are. Think out of the box. How much does it cost for the electricity to run your server room? This might be a hard one to actually facilitate because I've worked for lots of organisations where the server room, the data centre, has been in the basement of the office block where the staff all live, and the electricity costs are often hidden from the IT department because it's paid all up for that one building. But it's key to try and get that information so that you can compare like for like when you're comparing existing costs and cloud costs as well. Now, the next stage, once you've gathered all that information, is to start to assess it, start to pull it together and see how you're going to be going forward with your environment within the cloud. And this is where you start to strategize. Think about, is this workload going to the cloud? If it is going to the cloud, how is it going to look in the cloud? Is it actually staying on-prem and we're not actually going to move it into the cloud? And some of the information that you've collected will help you guide the answer and help it be an easy answer for you, hopefully. A great example is you might have a server that's brand new, it's 6 months old, it still has that new server smell about it, it has the latest operating system, it's built on using the best practices. It could be a Hyper-V host running a bunch of virtual machines that have, reliability. They have, a cluster built onto it. Whatever it might be brand new for you, and it might not be appropriate to move it to the cloud. Whereas the server that's creaking in the back of the data center that's 10, 12 years old with a really old operating system on top of it, and you're struggling to keep it alive and it has no resilience and no backup in it, might be an ideal workload to move to the cloud. So decisions will be made on the information that you've gathered, and that's why you have to gather so much information, because so many parts of that information can lead to you actually designing what your workloads look like in the cloud. There are also things you need to think about in terms of monitoring and backup and disaster recovery. Like I was saying, you've gathered that information and now you have to strategize how it's going to look going forward. Does your existing solutions for your monitoring and your backup actually fit within the cloud? Can it back up and protect and monitor workloads within the cloud? Or do you actually have to start looking at a new product that can work in the cloud and on-prem as well? So these things have to be strategized and thought about, because they're key components to this migration project as well. A migration project isn't just taking that virtual machine from on-prem and putting it up into the cloud and that's it. There's other things that support all of your workload and your virtual machine running. So think about your monitoring, your backup and your disaster recovery. What can you use and what is going to be the monitoring strategy going forward as well? Now, you might be running an IT department where you have traditional roles of IT infrastructure and developers and maybe database administrators, and your database people and your developers have to go through the infrastructure team to get anything done. Everything gets filtered through the infrastructure team and they take care of it. You could continue that model within the cloud, or you could start to think about how you can give your developers and your database administrators access to do some things and have a bit of autonomy themselves. Maybe you want to introduce a DevOps culture where some of your infrastructure people work with your developers, start to skill up on various different things and work together differently. This is the time to start to define that, start to think about it, start to think about how you can introduce that within your IT department, and again, support your staff on this new journey and this new defining role for them. You should also be thinking about timescales and how much it's going to cost you to actually do this migration project and how much you need support from your organisation to actually implement it. Your timescales could be driven by your migration trigger. Like I said earlier on, if you're moving out of your data centre because the lease is running up, your timescale might be defined by that lease. So it might be a year ahead of time and that's all you've got. You've got 12 months. Or it could be another trigger that started off this project that doesn't necessarily have a time scale, and you're going to say it will take us 2 years and that's how long this project will go. But you need to understand again those time scales to put in realistic understandings and to help you plan that budget. Do you need to get more money for overtime, because a lot of these migrations might have to happen at night, because again you've collected information about your workloads and found that no one can survive on an outage during the day, so you have to do it out of hours. These things need to be thought about and they need to be planned and they need to be documented about how you're going to be moving forward, because this information is going to be critical to probably getting the approval to further go ahead with this project after you use all the discovery information to strategize it out. Now, there are also things you need to think about when you're moving to the cloud, and this is around the governance of how you're going to run your resources within the cloud. Now, don't panic, you do not need to know all the answers to everything right now, but you need to start thinking about it. You need to start thinking about how it will affect you in the long term and how you're going to run your operations when you move into the cloud. Things like cost management are going to be key when you're moving into the cloud. Gone are the days of investing maybe once every 3 or every 5 years into your IT department and not thinking about it again. The running costs within the cloud differ very much. You're getting charged per minute, per hour, per day, per month, depending on what the resource type is that you're using. And you need to be more on top of that budget on a regular basis. So you're going to have to start to factor in how you do that and who does that within your organisation. And a quick hint, it should not just be the IT department that are taking on that responsibility. There's also things like the security baseline. How are you going to secure your workloads within the cloud? Within the cloud, you have this shared responsibility model. So your cloud provider will take care of things like the physical security of your data center, but you're more in charge of what happens at the data level. How are you going to stop harmful people getting into your data? You need to make sure that you have the appropriate ports open or closed. You have appropriate password policies in place. Lots of different things that might have to change slightly when you're moving into the cloud, or you have to change your focus on how you attack the security baseline for your organization. Deployment acceleration is also something that you need to think about. How are you going to deploy the resources within your environment? Are you going to be using a manual process? Are you going to be using the GUI within a browser? Or are you going to use some kind of automation? Things like Terraform or ARM templates or Azure DevOps. Are these going to be aids towards how you manage your resources and how you deploy them? Now again, you do not need to answer all of these questions before you embark on your migration, but you should start to think about them. Especially examples are like the deployment acceleration. You might not have the skills in-house currently to use Terraform, for example, to deploy your resources and manage them, but you want to be at that stage where you can manage your resources and deploy them using Terraform. And this is an ideal stage to say, right, we need to go and learn Terraform. We need to go and send some people on training courses, buy some resources, buy some books, give them the lab facilities to try that and learn that. So that in maybe 6 months' time, you are in a better position to actually start to automate and deploy things with Terraform. Now, you should also be thinking about defining and designing your landing zone. When we talk about a landing zone, we're talking about the minimum viable things that you need within the cloud in order to support your workloads. And if you think about it, if you were standing up a physical data center, you would need some things such as a power socket to plug your server into and an internet connection to provide you connectivity to the rest of your environment or even just the wider world. And those are probably two of the things you would need at a minimum to stand up a data center. There's lots more, obviously. But think about that when you're moving into the cloud. What are the minimum things that you need in order to actually deploy some resources to the cloud? You know, for example, it's a simple one would be a subscription. You do need to have a subscription service where you can, you've put in maybe your credit card in order to be able to get so that the provider can charge you for hosting those resources. There's lots more to think about in terms of the landing zones and different things, and it will depend on how you're hosting your workloads and what kind of workloads you're hosting as well. But start to think about that, start to do the research, start to design that and figure out what you need for your landing zone within the cloud. Now, how is also an important thing to think about at this stage. Lots of organisations embark on doing this migration project themselves. They do it with the in-house staff that they have. They try and juggle the project work and the business as usual work and do it all in-house, and that's absolutely fine. Lots of organisations go down that route. However, there are companies and partners out there that can specialise and help you with a migration project. They specialise in migration projects and can bring all of the knowledge from other customers and other customers' projects and bring them into your organisation and your project. However, they wouldn't have the personal experience of your environment to be able to do that, and you would have to complement them with some of your in-house staff. So again, you need to think about whether you want to go down that route, whether you have the budget and the timelines to support bringing other people in, but it's also something you should be thinking about and leveraging if possible. Tooling is something, again, at this stage you should be evaluating and having a look at and how it can complement you and help you on your journey as well. Again, at Microsoft, we have a tool called Azure Server Migration, and it can help you migrate your servers into the cloud. But there are other tools as well that can complement this, and I think it's key to have another look, have another point within your project to go out and investigate and interrogate these tools that can help you with the migration as well, and try and speed it up and make it more efficient and easier for you as well. Also, look at things like your backup or disaster recovery tool. They might already have some facilities you can actually leverage to help you migrate workloads into the cloud. There's different avenues to take, but definitely a touch point at this stage in your project is evaluating the migration tooling that is out there already. You should also be thinking about designing a communication plan. As I said at the start, people are a massive key factor within this project, and keeping those communication lines open to your end users, your business users, your stakeholders and your IT department will help make or break this project. So make sure there's a communication plan in place and everybody knows when things should be happening and they are aware of what's going on with the project. Now, hopefully you'll have got through the discovery, you'll have got through the assessment and the strategizing, and you'll have had the go-ahead from your leadership team to actually start to do the migration. And this is the exciting stage. This is when you actually start to get to play with the technology and actually start to implement everything that you've designed and put it into practice. You should be starting small. You should be starting with the less critical application within your workloads to move first of all, because chances are there's going to be something that you've forgotten. There's going to be a checkbox or something that's going to come unstuck, and you're going to get some issues with the first workload that you move. So if you use one that isn't mission critical to your organization, then chances are you'll get away with that mistake and no one will notice, and you can grow as you go. So start off with a small non-critical workload and then work up to the most critical workload within your environment. It'll help you understand the process, test your processes, and grow with confidence, and also help to communicate to the business that the cloud is the right way forward. You don't want to start off with a workload peppered with issues and then everybody gets a bad reputation, and the cloud platform also gets a bad reputation. Now, it goes without saying that testing should be a massive part of this stage. Testing before you migrate your first workload, testing after your first workload has been migrated, and continually testing throughout the process. You should be testing at an IT level, so making sure all your systems are up, all your management tools are communicating with the workload once it's moved into the cloud. But you should also be testing that workload for functionality as an end user as well, either by having an end user actually test the workload once it's migrated, or having that end user give you a step-by-step guide as an IT person to go through and test the functionality of the workload. And again, this is where the communication early on in the project can really come into play. If they know ahead of time that this is happening and that's going to be an ask to set up to either be part of the testing process or to provide some testing documentation, then they'll be prepared for that ask when you come to them. If you come to them the night before the migration and ask them for either of those things, chances are it's not going to go down too well. So again, those communication channels are very key to how this project can go, good or bad. Again, communication and documentation is key to this project. The last thing that any of you want to do is move your workload, say at 2 in the morning because you've had to do it out of hours, complete the migration, think it's all successful, and then when the first person comes in the next morning, there's an issue, and someone in your IT department who didn't know about the migration the previous night goes, oh no, the server is turned off, runs into the server room, powers on that old server, and suddenly you've got the old server serving data requests as well as having the new one somehow not running fully functioning, and then you end up with more problems. Even if your communication plan is just a post-it note or a sticker across that power button on that physical server to say, do not turn me on, phone someone on this number if there's an issue, that is acceptable in the interim, but make sure again that long term you're updating the documentation, updating the processes, and making sure that the communication avenues are clear as well. As you grow through this migration project, you might start off doing everything manually so that you have a feel of what it is, so that you understand the touch points and what you have to do and when you have to do it. But as you grow through the migration project, then the chances are you'll find the steps that you can automate. Try and make it more efficient, try and make it faster, try and take out that human error element that can be in it as well. So try it once you're moving along this project, take all your learnings and see if you can actually automate any parts to make it much more quicker and easier for you to migrate future workloads. Everybody's migration project or step within the project is going to be different depending on what type of workloads they're migrating, how many workloads they're migrating, and what those workloads actually look like. But if you stick to some of these key lessons that I've shared here, then hopefully your migration stage will go quite seamlessly and painful free for you. And again, this might take several months, several years to actually complete, but it's all about taking each learning from each workload that you migrate and building on that success and making every workload that's migrated better and easier for you and your organisation. Now the fourth step, the last step, is secure and manage. And again, like I said at the top of the presentation, arguably these kind of methodologies will be sprinkled across your project already. But this is when you start to think about everything is moved into the cloud now, and how do I operate? How do I go ahead and run my business, my IT equipment in the cloud as a day-to-day business? What does that look like from a business as usual point of view? And that's thinking about things like cost management, as I said at the start. Cost management is very different within the cloud, and this should be something that you are looking at going forward. You should be thinking about how you review costs and who reviews the cost. I said earlier, it shouldn't just be the IT department, it should really be a team sport. It should be people within your organisation helping you understand the costs and driving the innovation and driving the costs down where appropriate within your organisation as well. It shouldn't be something that you're doing on a daily basis, probably something you shouldn't be doing on a weekly basis, but it's something you probably want to think about doing either on a monthly basis or a quarterly basis, depending on how your organisation works and how much time you have to invest in this. Having it at those regular touch points will give you enough data to make informed decisions about things that maybe need scaled down, things that maybe need to be shut off because they're costing too much, or redesigned because they're costing too much. But it will also give you enough frequency that if something is running out of control, if something is spiraling out of control in terms of your budget, you will catch it early enough. But again, please don't make it a daily routine. I have seen organisations focus so much on the cost on a daily basis that they forget to do the other business as usual activities, or they forget to use the cloud and benefit from it properly. They get so sucked into cost management that all the benefits of moving to the cloud are outweighed completely. You should also be thinking, like I said, about training. What is the long-term plan for your training? How are you going to operate within the cloud, and how are you going to keep those skills relevant? Like I said, the cloud moves so fast. There's constantly new features, there's new functionality, new products being added. There's also some things being deprecated that you need to be aware of that could impact your business. So how do you keep on top of that? How do you help support your staff keep on top of that and make it something that they are always learning and always growing, so that they can iterate and grow from there onwards? Now, hopefully you've got this successful project and all of your workloads are running in the cloud, or the majority of your workloads are running in the cloud, and you've picked up some hints and tips from me today. What I want to do is just summarise some of the key learnings that I've touched on throughout the project. The first one is to make sure you have a success metric for this project. Make sure you understand where success lies within this project, so that you can mark it either as a success or a failure, and you can move on to the next project as well. Remember to include the business and involve them at every step along the way. They will really help you with some of your decision points. They will help you assist with testing of things when you move them into the cloud, and it'll just be much more seamless if you do speak to them and keep those communication lines open constantly throughout this project. Try and script and automate where you can. No one wants to be sitting there clicking buttons every night. So try and script and automate things, so again it's more efficient and it's more reliable, and you're not introducing too much human error element into your project as well. And that's a great tip going forward as well. Once you're in the cloud, try and script and automate things as much as you can, so that again you can free up people from doing the mundane tasks, and they can start to really drive innovation within the cloud and within your organisation. Please do evaluate all the tools that are available out there on the market and pick the right one from you. As I said, I've seen a lot of organisations pick the wrong tool based on wrong assumptions, and they've not really done the full investigation. They might have seen that the price point was free and just went with that, and it's not been the right tool for their organisation or how their network is actually set up, and they've had to stop, bin that tool and pick another one, and it's cost them in terms of their timeline, and it's also cost them in terms of the reputation of the IT department with their bosses, etc. So make sure you're evaluating all the tools that are out there and picking the right one for your organisation. And last but not least, track and optimize your spend. It is important within the cloud. I can't stress that enough, that you are tracking and optimizing that, but don't get bogged down on doing it all the time. There are other things you can be doing within the cloud as well. Now, I've spoke a lot today. I've shared a lot of tips and tricks and talked about different resources and different tools that are out there that can help you. What I've done is collated all of that together into a website where you can go and have a look at some further reading and spend some more time talking and reading about some of the things that I've spoke about today. So hopefully that'll be useful, and they're all behind that link on screen right now. Thank you so much for taking the time to spend with me today. I hope you found this presentation useful. Like I said at the start of the presentation, my contact details are on screen. Please do reach out to me if you have any questions, any comments. I'm happy to take them. And again, I hope you've had a useful session today. Thank you so much, and I'm looking forward to what's happening for the rest of today's agenda at this event.
The session has now concluded. Make sure to download your handouts at petri.com/conferences or find the links down in the descriptions below. We'll have more sessions starting up here shortly.
The load balancer's privileged position in the network means it's ideally situated to power always-on application experience, AX, ensuring resilience and total flexibility wherever applications are deployed and wherever you are working from, home or office. Kemp load balancers are available as a virtual, hardware, cloud, or bare metal load balancer, offering hundreds of features, supporting thousands of applications, including the collaboration and meeting apps used by today's remote workforce. Application templates for all major workloads simplify deployment and guarantee best practice delivery. Load balancing across public clouds, including Azure and AWS. Deployed on all major hypervisors to deliver the intelligent workspaces and desktop virtualization that boost collaboration and replicate in-office environments. Customers in 115 countries with over 100,000 deployments, all depending on one application experience expert, Kemp. More simplified deployments, more flexible licensing options, world-class direct technical support, unmatched value and cost savings. Take control of your application experience at kemp.ax.
Welcome and thanks for joining me for Kubernetes up and running in an hour. So regardless of your level of experience with Kubernetes or DevOps or Microsoft Azure or developer tooling, together we're going to get a Kubernetes cluster up and running in Azure. We're going to deploy a containerized application and test it all in just a few minutes time, and you'll see that this is much easier than you might imagine. But at the end of the day, I want to give you a simple path and some tips and tricks along the way to make your journey as quick and easy as it can be. Hi, my name is Pete Zerger. I'm a Microsoft MVP in the Azure category. I'm a CISSP and a virtual Chief Information Security Officer for some of my customers at Lumigate, where I work. Love to connect with you on social. You can see my LinkedIn and Twitter details down there. I also have a YouTube channel called Inside Azure Management, where you can find all sorts of videos on how to do things in Azure and Microsoft certifications. So we only have a few minutes, so let's get right into it. And in step one, we're going to clone a Git repository from GitHub. We're going to get our files down into our Azure Cloud Shell instance. And you might say, Pete, I'm not familiar with Git and I've never used the Azure Cloud Shell. You're going to find the technique I give you here. This is all so simple. Experience just doesn't at all matter. So I'm going to go over to my browser here. And I'll start with Azure Cloud Shell. Essentially, you need to log in at shell.azure.com. And about the only resource we're really creating here in Azure in the background is a storage account. So you'll create a storage account. I have just an old V1 general purpose storage account sitting back there. And I've logged in with my Azure AD account. Now, with Cloud Shell, we have a couple of options here. We can use Bash or PowerShell. And Bash means we're going to use the Azure CLI. Now, if you're a PowerShell person, I want you to go down the road of the Azure CLI, the Bash shell with me today, and we'll talk about why in just a moment. But it's going to have a positive impact on your overall capabilities and really enabling you to make a splash in the job world. So I'm going to go over to GitHub, and I'm at our 100 Days of Infrastructure as Code in Azure repository. This is where I'm going to park the source code so you can have all the instructions and all the source code that I run here today, so you can cut and paste your way right through this. So to clone my repository into my Cloud Shell, all I have to do is come to this nice green code button and click there. And you'll notice here there's an option called GitHub CLI, and this is fairly new. And I'm just going to copy the GitHub command line that I need to clone this repository, and I'll right click and paste. And so GH is the GitHub command line. It's actually present in your Azure Cloud Shell by default. Nothing for you to do. So I'll hit enter, and you'll notice here it gives me a prompt. Hey, you need to log into your GitHub account. I just want to walk you through this process. So it's asking me to choose GitHub or my enterprise. So I chose github.com. I'm going to log in with a web browser. We're going to keep this all browser based. And you'll notice here it says, hey, copy this. And I've copied that one-time code. I'll hit enter here. And you'll notice here that it actually failed to open the browser. So all I need to do is click this link to open GitHub in a new tab. And I will right click there, and I'm going to paste that code in. So that's all there was to it. I'm going to authorize GitHub to log me in. It's going to say, hey, prove to us who you are by giving us your password. But what you see here is I don't have to have any real Git familiarity. I'm not running complicated command lines. I'm simply authenticating to Git and running that command line. So I come back to my Cloud Shell window. It says authentication is complete. I'll hit enter to continue. And I'm just going to use HTTPS. So I took a lot of defaults there, and now I'm ready. So I'll just hit the up arrow here and get back to that clone command. I'm going to clone one more time, and now that cloning process is going to begin. And you're actually cloning the entire 100 Days of DevOps, 100 Days of Infrastructure as Code repo, so there's a lot of source code here. But you'll have the code we need for this exercise today. And again, that's all there is to it. And all the step-by-step is available for you in
the document that comes alongside the code sitting in the 100 Days of IAC repository. So in 5 minutes time, step 1 is behind us and we're ready to move on to creating resources in Azure. So step 2, we'll start by creating a resource group, which is going to host our Kubernetes cluster. And creating a resource group in the Azure Cloud Shell with Azure CLI is very simple. It's a single line of code. And again, you're going to have all the step-by-step in the how-to that comes in the Git repo along with any source code. So in Azure CLI, we use AZ group create to create a resource group. I called mine MyKatesRG, and I'm going to put that in East US. So resource group creation happens almost instantaneously. Very little to see there. And I can see here in the JSON output that the provisioning state is succeeded, which means my resource group is there. I could actually come over to the Azure portal and just do a quick refresh here, and I can search for my KatesRG. And there, in fact, I see my resource group. So step 2 is complete. And to say that took 5 minutes would be really overstating reality. So in step 3, we're going to create our Azure Kubernetes Service cluster. And we're actually going to do a little better than just create our cluster. We will actually set our monitoring up as well. And so I'm just going to switch over to my Azure Cloud Shell, and I'll show you the command line we're going to run here. So you'll see that we're running the AKS create command. We're going to specify that resource group we just created. I'm going to name this my AKS cluster. I'm going to keep this simple. You do want to make sure your naming is unique because you'll have collisions otherwise. And since we're testing here, I'm just going to deploy one node, so one virtual machine that will host my containers. Now the cluster management, the management nodes are handled for me in the background by Microsoft. So with AKS, this is a managed cluster right out of the gate. Now I want you to notice the enable add-ons monitoring area here. So when I specify this parameter, what it's going to do in the background is create the log analytics workspace needed to host Azure Monitor for containers. And so I have monitoring for my Kubernetes cluster in Azure right out of the gate. And you'll see it's going to generate the SSH keys that I need to authenticate for me. So a lot of the heavy lifting happens here in a single line of code. And so this is running. You'll notice we get a note here that the keys have been generated. This is going to take, for a single node, 5 minutes or so. So while that's running, let's go have a chat about why you might want to use the Azure command line. So I want to just have a chat with you here. So PowerShell is a language virtually everyone uses these days. It's ubiquitous. But I'm using Azure CLI here. And the reason I'm using Azure CLI and I'm not using PowerShell and I'm not using ARM templates is I want to give you what I'd call a more inclusive option. So what's great about Azure CLI is it's essentially Bash. It's very friendly for folks who work on Linux, who work in the open source world. So if I know Python, if I know Bash, Azure CLI is going to be very simple for me. So if you need to reach across the aisle to folks who work with Kubernetes in the open source world on Linux, Azure CLI is going to be a way for them to step into the world of Azure and not have to learn a new language like PowerShell, not have to learn ARM templates in depth, and it makes for a great first step. So the other thing I love about Azure CLI is it's actually your create commands are idempotent. So when I specify AKS create here, if the resource I'm trying to create here already exists, the create command is going to detect that, and it will not create a second cluster. Now, if I've removed some resources, it can potentially plug those gaps for me, but you're not going to wind up with multiple clusters of the same details running this command. So Azure CLI is idempotent, and ARM template is idempotent and declarative, which is really the top of the mountain and where we like to be when we're working in a CI/CD pipeline. But when you're getting yourself acquainted with Azure, with Kubernetes and containers, Azure CLI is a sweet spot for a lot of people. And if I backtrack and talk about PowerShell, PowerShell is neither idempotent or declarative. So it actually lacks one of those core properties of the Azure CLI. And as you can see, the Azure CLI syntax is very simple, and the help is actually quite nice. You can actually just add help to the end of a command and get the help you need in line as you're working with a commandlet. You don't necessarily need to go search the internet or to know any fancy syntax. It's all available right here. So we're going to pause for just a minute while our cluster finishes deploying, and I'll be right back to you. There we go. That only took a couple of minutes, so we're still deployed in 6 or 7 minutes. And if I just scroll back through the resources here, you see there's a lot of JSON output because we've deployed an AKS instance here. We have a managed Kubernetes cluster. So if I just scroll down here, you're going to notice the log analytics workspace. So I'm going to have that Azure Monitor for Containers capability right out of the gate. I'll scroll down here. I see my agent pool. So I have my node available to me so I can deploy applications immediately. Keep scrolling here. I can see the FQDN right there of my API. I'll keep scrolling. There's my SSH key data. And if I were going to go set up a CI/CD pipeline, after this, I might copy that key over, as that might come in handy later. But what we'll see with the Azure CLI and our Cloud Shell here, per that notice we had, the key's already been written to disk for us into our storage automatically, so we don't have to worry much about it. Keep scrolling here. Here you can see my location. You can see the details of my node, and I've got a single node, a single IP address. I can, for a production scenario, deploy multiples. And really what that would mean is I could deploy multiple nodes. So the nodes are where I run my applications, but I could also deploy that cluster that Microsoft manages in the background. I could ask for some redundancy there as well. So instead of having a single node cluster, a single manager, I could have 3 managers, for example. So I can build the level of redundancy in that's appropriate for my situation. So when you're working in the lab, a single node setup is just fine. If I scroll down here, I just see a lot of success messages here letting me know that everything deployed as promised. So you may remember we saw that the SSH details were written down to storage automatically when we deployed our cluster. So now I'm ready for step 4. So in step 4, I'm going to connect to my AKS cluster. And actually what we're going to do is run a simple single line command that will download our credentials and configure the Kubernetes CLI to use those creds so we can connect to our cluster. So this is going to be the AZ AKS get credentials commandlet. We're going to point it to the cluster in the resource group myk8rg, and the name of my cluster is my AKS cluster. So I run this and I simply get a note back that we're pointed to the right cluster. So it tells me that's my current context for kube control at the command line. And really about all I need to do here to verify that I can connect to my cluster, I'll just try to pull back a list of the nodes. So the nodes of the VMs in my cluster where I can run my containerized application. So if I just run kube control get nodes, it should return the nodes in my cluster. And here I see my node pool. It's really a pool of 1 in this case. It says there's the agent and the status is ready, gives me the version info. But there we have it, step 4 complete. So now we're ready for step 5. We're ready to run our application. But before we do, I want to switch over to the Azure portal and I want to show you the result of adding that additional parameter to enable monitoring. So we added the -- enable add-ons monitoring parameter, and what it gives us, if I just come to the portal and select all services, I'm going to look for Azure Monitor. And when Azure Monitor comes up, I'll scroll down to containers and I should see a monitored clusters tab here. And there is my AKS cluster. And you'll see it's a 1-node cluster, has 8 pods already deployed. There are a lot of system pods with Kubernetes that are deployed in the background. And you can explore that both from the command line and in Azure Monitor for containers. But what you're getting here is native monitoring with a minimum of effort. So really all I had to do was supply that additional parameter. I didn't have to pre-create this workspace. There was nothing of that nature. So it was very, very quick, very simple. I'd like to say it's getting monitoring for free. And if I just go to services and ingress here, I can see some of the system components of my Kubernetes cluster. So the system components are generally in this kube-system namespace. I can come down to my node pools. So this is where my nodes live. So you'll notice in this node pool, there's only a single node. So in a production scenario, obviously we'd deploy more. But if you're not familiar with Kubernetes, this is also a great way to kind of explore your environment. Just walking through what you see here in the details of your cluster. So we can look at storage, we can look at networking, we can look at the scale option here. So you'll notice here that all the scaling functionality has been moved to the node pools menu. So you could go back here, and if you wanted to scale, we could come back here and scale. So you'll notice here I can also flip that scale from manual to auto scale. So I have a lot of configuration I can do here right in the Azure portal, even if I don't know a tremendous amount about Kubernetes. So I'm going to go ahead and leave this to manual because we're in a lab environment. And you'll see I also have an upgrade option here. So if we need to upgrade the VMs in our node pool to a newer version of Kubernetes, we can do that right here on the node pools menu. And you'll see some visual indicators when there's a new version of Kubernetes out there that you can deploy. So you'll notice here it mentions that we are on the latest version, which is no surprise given we just deployed. Then one more node, as you're getting comfortable with Kubernetes, one more node you want to look at in this menu is workloads, where you can see some of the default workloads that show up here. You have some containers running that are really system components that handle some of the core functionality of our Kubernetes cluster. So if you see here, we have some pods running in the kube-system namespace, DNS, there's the autoscaler. We see the metric server, which you can imagine relates to gathering performance data. And then you'll see the OMS agent. So there is your monitoring element. So we've got our monitoring, we've got that metric server that's aggregating performance data from across the cluster. We have TunnelFront, which is actually another system component that just facilitates secure communication from our control plane to our nodes. So really from the management cluster that's behind the scenes and out of sight for us to the nodes, to the virtual machines where we're going to host our workloads. So that's our grand tour of Azure Monitor for containers. So just a quick intro to the monitoring component. So now we're going to deploy our application. So I'm just going to see where I am on my Cloud Shell, and I need to change directories here over to the 100 days of infrastructure as code, which we synchronized earlier back in step 1. And I'm going to go to the articles directory and then to the Petri directory. So this is where we're going to find the resources for this session. So there are 2 files out here. One are the step-by-step instructions, which will be linked out on the homepage. And then there's the YAML definition file of the Azure voting app. So you'll also find this where you can cut and paste out of the article, but we've synchronized it here so it's ready. Let's go ahead and open this up. I'm going to open this up in the VI editor, which is just a very standard Linux editor, and I'll type votingapp.yml. And so this YAML definition file is very detailed. It lays out the back-end and front-end components of the Azure voting app, describes the necessary container images, establishes resource levels, ports, the services that are ultimately going to be deployed and running in the pods on our Kubernetes cluster. And if I just scroll down through here, you can look at this, on your own because you'll have it in hand. But even down at the bottom here, you'll notice that there's even a load balancer deployed. So to get out of this with no changes, I'm just going to hit escape and then :Q exclamation. And there I am. So that is my definition file. And remember, we are already focused. We already have the kube control, the Kubernetes command line pointed to our cluster. So we're ready to deploy our application from that YAML definition file. And the syntax for that deployment is going to be kube control apply -f and then the votingapp.yaml, so our definition file, and I'll hit enter. And this will deploy in just a few seconds. It's a containerized application. It's pretty lightweight. It's going to grab the components it needs and deploy those pretty quickly. And you see already we're up and running. So we're ready to test our application at this point. Before we do, I want to just give you a bit of a tour around the Azure Kubernetes service in the Azure portal, and then I want to show you around the Kubernetes CLI, kube control. Going to show you how to explore your environment both through the UI and then through the command line, which would be traditionally how we do it before we were working in Azure. So in the portal here, portal.azure.com, I'll go to Kubernetes services here, and I'll click on my AKS cluster, and we'll kind of look from the top down. So you have this concept of namespaces, and then you have 4 namespaces that are created by default, and namespaces are typically used in environments that have many users with deployment spread across multiple teams. So the names of resources need to be unique within a namespace, but not across namespaces. Now, these 4 default namespaces include 3 namespaces that you're not going to pay much attention to. You've got kube system, which is a namespace for objects created by the Kubernetes system functions. You have the kube-public namespace, which is mostly reserved for cluster usage. So it has to be visible and readable publicly throughout the cluster. But you're not going to mess much with this either. And then there's kube node lease, which is a fairly new namespace in the lifetime of Kubernetes. But with Kubernetes, you have 2 types of heartbeats. You have kind of a node status, and then you have a lease object, and that lease object sits in this kube node lease namespace. Now, the namespace you will pay attention to right out of the gate is the default namespace. So if you deploy a service sitting on a Kubernetes cluster, if you don't specify a unique namespace, default is where it goes. So when we deployed the Azure voting app, we didn't specify a specific namespace, so default is where it went. And just to touch on a couple of other items we haven't spent much time on. So if we go to services and ingresses, so ingresses are what handle the inbound communication to services on your cluster. So that's typically going to be handled through a load balancer. So we can see here with our Azure voting front end, we've got a load balancer there with an external IP, so that can route traffic to the application on the back end, essentially. If we had persistent storage, so storage that needed to persist even if something happened to the nodes in our cluster, so our application could connect, our containerized application could connect to that storage later, we go to the storage node here and we could add those persistent volume claims. Now, typically when you're deploying, those are going to show up in your deployment like in your YAML definition. And if I step one down further to configuration, what I see here are config maps. So config maps separate some non-sensitive configuration data like environment variables and port numbers and command line arguments from our containers and system components at runtime. So basically they keep our configurations separate from our pods and our components, which makes our workloads portable, but that's for non-sensitive data. So we'd use secrets for sensitive data, and you see there are quite a few secrets listed here by default. And again, since all this happens, in the background as part of that deployment, we don't have to worry about most of this. But as you're exploring Kubernetes, these are just good concepts to be familiar with when you come across them, because certainly if you're out at kubernetes.io just going through the documentation, you'll definitely see all of these terms at one point or another. Then I'll just go down to networking, and you'll see some high-level networking information here. And then you can check the HTTP application routing option. So this is a solution that just makes it easier to access your apps that are deployed to your cluster by creating some publicly accessible DNS names. So this is something worth playing around with, but it's HTTP, so it's not really recommended for production use, but it's a great way to just easily expose some apps when you're testing. And then just to finish up here and before we go over to the command line, when we look at node pools, these are the virtual machines where we're deploying our workloads. So what you don't see here are you don't see the compute that sits under the management components of our cluster. So in the old days, pre Azure Kubernetes service, we'd have a separate cluster that would handle our management components. And since AKS is a managed Kubernetes service, the compute under those services are kind of out of sight, out of mind. We can still see those services in the kube system namespace, but we're not really worrying about that other management those management nodes. In fact, because Kubernetes is a hosted service in Azure, Azure is handling a lot of that underlying maintenance and health monitoring. The Kubernetes managers are managed by Azure, and essentially we just pay for the agent nodes in our cluster. We don't pay for the those management nodes. It's part of the service. So let's switch over to the command line. My system's clear here, my screen's clear, so we can start with kubectl. And just like we did with the Azure command line, I can type help --help and get a list of all the commands that I can run from the Kubernetes command line here. So you see there's quite a lot there. So I'll just do kubectl get namespaces. And here I can see those 4 default namespaces. Now let's look at services. So we talked about services briefly earlier. So if I just type kubectl get services, so I see the Azure vote front and back here. So I see the application there. Now what I'm not seeing is every service that exists. I'm just seeing a particular namespace. So I'm going to I want to move from the default namespace and see more. So I'm going to type namespace all namespaces. Actually, I take that back. We'll actually do namespaces at the pod level. So give me just a second. We'll circle back on that. So when I'm looking at my services, though, remember the services identify a group of pods in my cluster that all perform the same function, basically using label selectors. The pods underneath are what we call ephemeral. A service enables a group of pods, and that group of pods will provide a specific function like web services or database or what have you. And the pods underneath, we'd actually just type kubectl get pods, and here I'll see just the pods from that default namespace. So if I did get pods namespace all namespaces, There we go. Got to get your syntax right. You have to tell it exactly what you mean, not your intent. So I type kube control get pods dash dash all dash namespaces. Now I'm seeing those pods down in the other namespaces down in kube dash system. So those are those Kubernetes system functions that I don't have to worry about because I'm in a managed environment. So there I can see all the pods that are running and how old they are. In fact, if you want to see those over in the portal, a good place to see those is to go to Azure Monitor for containers. And if I go down to the containers area here in Azure Monitor, I'll look at my monitored cluster. I'll get into my cluster. I'm going to look at my services. You're going to notice I have to drill quite a ways down because the services are what manage those pods, right? So I'm looking at my services, and here's my Azure voting app front end and back end. So if I just drill down, say, into Azure Vote Back, underneath here, I'll see the port that service is published on and its endpoint. But then I can go to the pods node here and I can see the pods that are running there. And, you know, in a production environment, I'd typically have more than one node running in my cluster. I'd have multiple pods, quite likely as well, to provide redundancy and scale. And then I can implement some auto scale capability where it makes sense. So we can go all the way down to the lowest level here, which is the container. So really the lowest functional level in Kubernetes is the pod, but a pod contains one or more containers. So now I'm down at the container level. You really don't need to be down here, generally speaking. In the world of Kubernetes, we're working with services and pods at the very lowest. So then just hopping back up a level, here's my pod, and then I go up one more level and I'm at my service. So it was service, pod, container. Then of course, remember, you know, in the world of Azure, we have role-based access control. So of course you can come in here and you have the access control area so we can address permissions to our AKS instance, to our cluster here. So you've always got that regardless of the resource you're deploying in Azure. But what you'll also see in Azure with AKS, you have some default roles for AKS. So if I just go to access control to IAM and I hit add role assignment, if I hit the role drop down, you'll notice that there are quite a number of built-in Azure Kubernetes Service RBAC roles. And if you just mouse over that little information area there, you can see the permissions that come with assignment to that role. So worth exploring this as well. And Microsoft has pretty good best practices out on their website as to how you should secure your clusters and authenticate to your clusters, because we can incorporate Azure AD authentication, for example. And then just to go back over here and finish up here, I'll go ahead and clear my node here. And again, if we just do kube control get services, we see that our vote app is running. We can get our IP address and we can basically go test our service, which is, you know, the last step here. We want to test the Azure vote app to see that in action. So let's get back over to the command line, prove our app is running, and then give it a live test. Well, so how can I prove that? Well, I can basically run another command. I'll do kube control get service, and Azure-vote-front is the front end of our app. And here you can see the load balancer front end, and you can see the external IP address. So that's the public facing address that I can use to retrieve my web UI for this application. And certainly we could look more broadly. We can take, you know, some of this off. If we just did Kubernetes, did kube control get service, you see here I can see my cluster IPs, and there's that load balancer. So I'm going to go ahead and focus on grabbing that public IP, because this is how we can access the application across the internet. You'll see the ports are already laid out there. So it's mapped to port 80, as you can see here. And so I'm just going to switch over, and you'll notice it says not secure because we're mapped to port 80, right? So in the real world, you'd use a certificate. You'd have TLS in front of this, but we're just using port 80 because we're in a lab environment. So this voting app allows me to vote for cats and dogs, and I can reset and essentially see this app is actually alive and working, and those components are working together over there in my Kubernetes environment, in my cluster. And what you'll find interesting as well is how quickly Azure Monitor for Containers will pick up these changes. So if I just switch over to my cluster and refresh here, you'll see that the Azure voting app is already here. I see the front and back end components in just a minute or two. And we can step down here into services as well. So while pods are the base component of Kubernetes, typically you're working with services, and a service is responsible for enabling network access to a set of pods. And so for our sample application, the Azure Voting app, you'll see that there is a service for the back end and a service for the front end. And you can see your IP address assignments there, and you can click in and look at the lower level data here as well, and even get down to a YAML file that shows you the definition of that service. And the front end service, the Azure Vote Front being the front end where we're accessing from the internet across port 80. But your takeaway here is certainly there's a fair bit to learn from the command line. So learning the Kubernetes command line, kube control, learning Azure CLI is going to be a bit of a process, but what you have here is really some cut and paste capability to do all of this before you've really learned. And by using that extra parameter to deploy your monitoring, you get this great UI where you can explore your cluster in a bit of a GUI interface, which all comes in really handy for sure as you're trying to make your way along. So last step, what if I want to just blow this away now that I've completed my deployment? I can actually run az group delete, and I can pass in the name of my resource group, and that resource group in Azure speak is the container where we store all of the components of an application or service that have a common lifecycle. In this case, the cluster has a common lifecycle. So when I want to get rid of my cluster and all the components therein, I just get rid of that resource group. So I'll run the az group delete, and within just a few minutes, that will have wiped that cluster clean. And that's step 6. So we were able to, in the span of just a few minutes, download our code from our Git repository on GitHub. Remember we use the GitHub CLI, so you didn't need to be familiar with Git. So remember that nice little green code button gives you access to the GitHub command line syntax you need. You can just cut and paste. So even if you've never touched Git, you don't have to worry about it. You can step right into being fully functional and moving along very quickly in that respect. And then we created our resource group, deployed our cluster, downloaded our credentials. And remember, each step, it was just a single line of code. It's very quick, very easy. And if I just switch over to my portal here and look at my cluster, what you'll see if you go find the cluster itself is it's going to show that it's deleting. So I'll just go find my Kubernetes service here, and it should show that it's in a state of deleting until it's actually gone. And there you can see its status is in fact deleting. So that'll take 5 or 10 minutes, generally speaking. But at this point, you can jump into the Azure CLI into a new command line. You can deploy a cluster, deploy a containerized application, test that application, download your code from a GitHub repository. Even if you've never worked with any of these technologies before. So you can download the code and the additional resources on github.com/starkfell/100 days of IAC. So you'll have the URL in the discussion area below this session. Definitely go out there, have a look at the step-by-step, and use it and enjoy it with my compliments. And should you have any questions as you're working through this example, as you're gaining knowledge around Kubernetes, by all means connect. You can find me. I'm Pete Zerger on LinkedIn. There aren't many folks with my name. I'm P Zerger on Twitter. And incidentally, if you want to connect over on GitHub, you'll find me at P Zerger there as well. So I hope you've enjoyed the session. I'll look forward to connecting on social. Be well, stay safe, and I'll see you next time.
The session has now concluded. Make sure to download your handouts at petri.com/conferences or find the links down in the descriptions below. We'll have more sessions starting up here shortly. And that is a wrap, folks. You can find links down in the description below to download the handouts from the speakers who put together information that are going to help you get up to speed on Azure and DevOps experiences that we talked about today. We want to thank our friends over at Kemp for helping out with us. Make sure to check out their load balancers and everything else that they have to offer as well. And we'll catch all of you right back here next time at our next virtual learning event.